Hello. I have more things than I need, I think, right now, but here we are. So I have the delightful position of moderating the first panel on streamlining embodied carbon reporting, and I am joined by four fantastic panelists. If you would like to come grab a seat, that would be wonderful. Yeah, you can follow your picture order if you'd like, but it doesn't really matter. We can we can be informal. We don't need to match. I'll look at you. So maybe I'll introduce myself first, and then introduce all of you, and then we can hear from you a little bit, and then we'll chat. So my name's Jeremy Scheinman. I am one of the co-chairs of the Decarb subcommittee with AIANY New York COTE. I am also one of the co-chairs of CLF New York City. And in my free time, I'm a project architect and senior associate at WRNS Studio, and do a lot of work at work within the embodied carbon space and building performance space more broadly. And I'm really excited to get to hear from all of these fantastic folks. Really diving deeply into a lot of really technical nitty-gritty understanding of EPDs and LCA and all of those fun things. So first, Ben is Managing Director for Software and Data at WAP Sustainability. He holds a PhD in mechanical engineering and has a background in lifecycle assessment, engineering design, and software engineering. Ben leads WAP's software development and digital EPD efforts and was the head developer for the first industry-wide EPD generator in North America. He has deep expertise in LCA and EPDs for construction materials and horizontal infrastructure and works closely with industry representatives and all levels of government to develop and implement sound lifecycle assessment policy and practice. Moving down the line, Rushita is an embodied carbon specialist as part of the high performance team with AICOM Advisory, where she develops practical, scalable pathways to low carbon and net zero design. She advises clients on comprehensive sustainability strategies and creates actionable roadmaps to reduce embodied carbon across their assets. Her work includes crafting effective low carbon strategies to meet ambitious carbon targets, evaluating and integrating emerging low embodied carbon materials, as well as applying lifecycle systems thinking to both material selection and broader decarbonization efforts supporting a circular economy. Rushita has also helped develop and facilitate a company-wide embodied carbon modeling training program for AICOM's Building in Places Academy. She contributes to Infra 2050, and where she specifically contributed in developing embodied carbon guidance for bridge infrastructure projects. Jack is the CEO and co-founder of C-Scale, a software platform democratizing access to whole life carbon data and design strategy. C-Scale was founded on the belief that data-driven tools can help get all hands on deck and in the work of transforming buildings and cities from a climate burden to a climate solution. In the last few years, he's presented research at over a dozen conferences a year, applied machine learning to streamlining early phase carbon estimation, consulted with the Biden White House on measuring and managing supply chain emissions from buildings, and led the development of LCA methodology and data solutions for hyperscale tech companies, Autodesk and Schneider Electric. And last but certainly not least, Peter is an ERG senior manager for standards and sustainable strategies with deep expertise in implementing embodied carbon metrics, requirements, and policy focused on environmental product declarations and lifecycle assessments through previous roles at Port Authority of New York, New Jersey, and the US EPA. While at the EPA, he led the development of numerous technical resources to support embodied carbon quantification, including the EPA's product category rule criteria, EPD criteria, the approach for developing greenhouse gas thresholds, LCA secondary data improvements, and represented the EPA on numerous standards committees. During his time with the Port Authority, Peter focused on integrating benchmarking and quantification efforts in active construction projects to support clean construction initiatives. Clearly, nobody here knows what they're talking about. So with that, thank you all again so much for agreeing to join me and be here. And we can jump now into some brief introductions from you about your work, and then we'll jump into questions. If you want to, right goes forward.
Check. All right, we're on. Thank you all for being here to relearn how to speak again. Ben Ciavola, I'm with WAP, now very recently part of SLR, Global Sustainability Consulting Firm. Here to represent the data generation side of the equation. So at WAP, we focus a lot on working with manufacturers and companies that create the materials that go into all the buildings that you're all designing. And we do that through, based on the topic of this discussion, you can probably imagine a lot of software work. So we operate a few different platforms. We have our Theta EPD generator, so we'll be talking about EPDs a little bit today. I'm sure you all have heard that term, and it's always nice to talk to a room that can spell EPD. We have a few different other tools as well. We manage the Open EPD standard, which is kind of the foundational technology for digitizing the product-specific carbon data in especially North America and increasingly worldwide. That's just a JSON-based, to get into the weeds, way of representing all the information you need to do the calculations on specific products coming into a project. And we also have EPD World, which is a platform for streamlining the process from you start by creating the LCA, doing the analysis, and then you have to get that out into the world, do verification, and we streamline that as well. Big changes happening in the EPD space. If you've ever sent an Excel back and forth, if you sent Word documents back and forth with verifiers and third parties that are checking it, really trying to streamline that process so that we can get data out to you in an efficient way. Let's see. So the real thing that we're focusing on at WAP is data interchange. How do we get all of our groups talking to each other, speaking the same language? Open EPD is the way that we do that. This is a technology, if you have ever used EC3, our team developed the EC3 technology, developed the Open EPD technology, and the goal is being able to get all these different systems talking to each other. So we're trying to get the sustainability space up to speed with modern software development and software integration standards. So it's all based around APIs between servers. So our systems can talk to your system, can talk to Jack's systems, can talk to Peter's systems, and that data can be used in an efficient and fast way instead of having to, the way it was done before, you would be hand copying numbers out of a PDF document into your own Excel format, and that is not okay. Absolutely not okay. And lastly, we are really focusing on how this data is aggregated and made available to people. So one of the things that we've seen really be a need in the community, especially this community, is the ability to find the data, get EPDs out of the databases that they're in and into your hands. So we have been working diligently to help solve that problem, taking the next step past the work that our team did with EC3 to develop databasing solutions that are fast, easy to search, and focused entirely around getting the data to you. So you are welcome to go and check out this site, openepddatabase.com, and start searching around, start looking at the EPDs that are out there. That's a really big step that we're trying to take, is just getting the data out of platforms and into other platforms. And we can talk more about that as we get deeper into this conversation. I believe Jack.
Cool. Hey, everyone. Really excited to be here on this snowy morning. For the past 5 or so years, we've been working on this project now called C-Scale that really is an attempt to bring more clarity to more designers about how whole life carbon assessments integrate into design workflows. There's a lot of amazing tools and approaches out there for compliance and reporting, and we need compliance and reporting for all the reasons that you might assume. But really what we've been focusing on is in helping designers make better decisions earlier in the process, so that whole life carbon thinking is not just something you report, but is a way that as you're moving through the project, you're making better decisions. And really crucially, the kind of problem we've been working to solve is that project-specific data usually isn't available until too late to inform these decisions, but the biggest opportunities exist up front. So for us, it's really been the process of building predictive models to allow people to input just a few parameters of the buildings, about a building, and understand maybe what some decarbonization measures like electrification or energy efficiency or lower carbon concrete might do to that building's overall footprint, so that people can weigh options from a whole life carbon perspective, not just in retrospect, but while the design is like fresh and alive and decisions are being made. To date, this has been mostly in sort of a cloud platform, but in the next few months, we'll be moving into the BIM environment to get closer to the sort of usually the single source of truth and design model here. So look out for more there. But really the idea is, as you're moving from early phase design into BIM and then forward into procurement, working with a contractor, to create more continuity throughout the process, rather than the kind of like herky-jerky delete and recreate that people need to do today as you move from one environment to the next.
Thank you. I'm Rushita Vora. I'm an embodied carbon technical lead with AICOM Advisory. Now at AICOM, we are very committed towards delivering a sustainable world. One of the ways we do that is by decarbonizing or reducing the carbon of the services we provide, the projects we deliver, through an approach called AICOM, through an approach called Scope X, which is essentially AICOM's approach to decarbonizing all the projects we deliver. What Scope X essentially does is bring together all our methodologies, frameworks, guidance, documents, techniques that have been applied on projects and have actually brought about decarbonization, our data and our tools together, so that on projects that we work on, we have a better understanding of where the carbon sits and have a better way of addressing the carbon and actually reducing it effectively. One of the key aspects of this approach is early engagement. So baking in embodied carbon or decarbonization conversations from the get-go. That means either including it in your scope or identifying low carbon measures to reduce that carbon footprint from the concept level itself. And as that graph shows, that it's very early on, that if you're engaged very early on, that's where you have the most effective measures and the most efficient way of reducing the carbon. One other thing that we use for our Scope X approach are our digital tools. At AICOM, we use a combination of industry standard as well as internal tools to see decarbonization throughout the design process, starting early stage and going all the way until the end of design and in construction. So based on the intent of what the analysis requires, we rely on the expertise of different tools to effectively decarbonize the projects. And I'm sure we'll talk more about this in the discussion itself. One last thing that I want to talk about is our decarbonization roadmap and how that integrates into our tools. So this over here is an example of our decarbonization roadmap, which includes multiple strategies addressing operational as well as embodied carbon reductions. Now, the tools that we build out internally capture these different strategies that are part of the roadmap and integrate them into the tool itself. So this here is a snapshot from our internal tool called AICOM 0. It's a parametric dashboard that includes all of these strategies. And what that does is enable us from the early design stages to understand which strategies have a higher impact towards getting us to that decarbonization goal. With that, I think I'll hand it over to Peter. Sorry.
No worries. Awesome. Good morning, everyone. Thank you for inviting us down, Jeremy. Great hearing everyone's introductions. I'll try to keep this brief. My name is Peter Backus. As you can tell, it's been a wild couple of years for me. I've recently joined ERG this past June. I'll let you all read into why I departed the EPA in June last year. But I've been really fortunate to really dedicate my entire professional career to implementing embodied carbon, using EPDs as a tool that can help us decarbonize our projects, as well as our products. Here at ERG, I've been really focused on working with public agencies to support their embodied carbon implementation goals and their decarbonization goals through implementing sustainable strategies, whether that's through just EPDs or other initiatives as well. Like Jeremy said, I was previously at the US EPA. I was there for a little over 2 years, really focusing on what are the efforts the federal government can do when we had billions of dollars behind us to really help supercharge the EPD ecosystem, to really support all of your decision-making in decarbonization. And this was really built on my experience at the Port Authority, where we were trying to use EPDs before EPDs were cool, in my mind. And I was just bugging.
They were always cool.
They were always cool, but it was very much just me yelling at Ben several years ago, being like, Ben, what am I looking at? So it was all built on actually trying to get EPDs into contract books, using EPDs to influence decision-making on probably somewhere north of $1 to $3 billion in annual active construction at the port. So keeping it a bit high level almost, decarbonization is completely doable, right? It's why we're all here. But it's really only doable and achievable at scale with systematic thinking at that system levels and starting to view EPDs as one of the tools that we can use to help quantify and benchmark our progress to date in active projects is not an easy thing to do, but a really important task. And so, I highlighted a few different decarbonization strategies. I'm sure throughout the morning, not just in this panel, we'll be talking through many of these. Things like looking into the circular economy. How can we achieve more closed loop systems, reusing materials, reduce our operational greenhouse gases, whether that's from tailpipe emissions, on-site energy use, on-site energy generation. There are tons of different potentials there in reducing our operational greenhouse gases. There's also green procurement or green public procurement, depending on where you sit, which is where EPDs really start to plug in, as well as efficient design. I'm not as a designer, so I'm going to not talk too much on efficient design. There are much more smarter people than me, not just on this panel, but in the room as relates to design. But all of these really plug into different strategies and tools. So, let's use EPDs as a tool to help decarbonize our products, because each one, we have whole project LCA for efficient design. We have C&D diversion goals for improving the circular economy, fleet decarbonization, alternative fuels, electrification, for reducing our operational greenhouse gases. And EPDs really come in and plug in at that green procurement or green public procurement. I was joking earlier this week before the blizzard hit everything. For context, I'm in Providence. My fiance got 40 inches of snow and still has not left her apartment. I beat the blizzard to come here. I caught some grief for that. But we were joking about this conference and the symposium, and we were talking about the Wizard of Oz because that's what we do. And we were joking about the whole lions, tigers, and bears, oh my. And I'm like, well, EPDs, whole project LCAs, and contract books, oh my. They're scary. But they can really help us decarbonize. So on that, thank you for having me here again. I'll turn it on over to you, Jeremy.
Awesome. Thank you all. That is great. And now we get to sit with our pictures. And I get to have, Peter and I will get to do a microphone dance, but I get to have the wonderful job of prompting these four incredibly smart people to share just a very small bit of all of the things they know with you in this wild world of EPDs and LCAs and digital decarbonization. So with that in mind, I think, or at least I hope it's kind of becoming clear already that there is this ecosystem that exists in the EPD and LCA space. All of these things are tied together extremely tightly. You can't really talk about one without talking about the other. You need to be very facile with your knowledge, able to jump scales, and maybe to kind of help build that knowledge base a little bit more. We'll do kind of another lightning round through here, through the panel, speaking specifically about what part of the ecosystem you all kind of work primarily in, but of course with the understanding that that's not the only place you live. So first question is to you, Ben, and I'd love it if you could help level set. I know this is hopefully not a 100 level discussion, but kind of start with some basic terminology to get everyone on the same page, because there is a lot of very specific information. So if you could help us with a few acronyms, as well as, so I'm looking specifically for LCI, PCR, EPD, and LCA, right? It's a little bit of alphabet soup, but these things are all extremely important in this space, and having kind of a foundational understanding will help. And then also talk a bit about what goes into actually making an EPD, what you need as far as inputs are from a data perspective, and how you think about that.
Okay, so that's a semester-long class.
No pressure.
I will do my best to make it engaging and compressed into just a few minutes. And of course, there's enough acronym soup that I have to pull out notes and remind myself which ones to even talk about. So I'm probably going to take those in the reverse order. Start with LCA, so life cycle assessment. It's the term for all of the work that we do around measuring environmental impact of the manufacturing and use of artifacts that we build as humans, and the activities that we do. So life cycle assessment, I think, is really cool. I like that you mentioned the different scales, because it is kind of a recursive thing. Once you do an assessment of one system, you can embed that in an assessment of another system. And that's a lot of what's going on, especially when we talk about material LCA, when you're doing steel or concrete or glass, versus a building LCA, where you're looking at all of the different materials that's going into a project. And then in the whole scope of the life cycle of that building, including operational and decommissioning of the structure. So it's the same set of tools of looking at the energy and the materials and the wastes associated with each phase of something's life cycle. To do that effectively, we need some extra tools. We need to build some structure for ourselves around how we do that analysis. EPDs are the tool that we have aligned on for sort of the highest quality data. EPD is an environmental product declaration. I joked about spelling EPD earlier, and the number of times I catch myself spelling EDP in a document and having to go edit it is still a little bit embarrassing. But an environmental product declaration is a shorthand way of communicating the results of a life cycle assessment. There are a standard set of metrics that are reported. There's a standard set of information about the LCA that gets reported in a short form document, and increasingly in a digital version of that document that is machine readable and machine interpretable, that allow you to understand the impacts of one unit of something, and without the producer of that document, without the producer of that material having to give up confidential information. Because once you start getting into the data that you need to collect to create that EPD, you're getting deep into a company's processes, their technologies, all of the things that give them a competitive advantage in the market. So an EPD is a standard way of communicating that information, and is really the thing that we're really trying to push everybody to use because of that quality. To get to an EPD, you have to have a PCR. PCR is a product category rule. That is a document, a much longer document, usually developed by a group of experts in that field, a group of LCA experts, a group of industry experts, people who understand the production process and the use of that material or technology. Peter sits on a lot of these committees. I've sat on a number of the committees, and it is an arduous process. Some of these, the high quality PCRs in the United States have gone through over a decade of refinement. Numerous background LCAs that go very in-depth, oftentimes engaging academic institutions and industry experts to really do a deep dive in all of the different ways that you could possibly evaluate a material, and coming down to the one that makes the most sense for the application. And that application in this case is largely procurement. We want to be able to compare materials, especially within material categories. So what we do in a PCR is we set the rules that an analyst has to follow. We try to take power away from that analyst and tell them exactly what they need to do, so that you can compare the results of one group's analysis with the results of another group's analysis, and ideally implement it in software so you can do it at scale. And that's what really started in the kind of the concrete asphalt spaces in the United States. Our company built some tools around that. There's a few others out there as well, to create these documents for products in a product-specific fashion, for a facility-specific fashion, even a batch-specific fashion if you're talking about things like concrete, so that you know the real specific, I'm going to use that word a lot, specific, information around the material that you're actually getting, so that when you have a delivery that's brought to your construction site, you can say, this is how much carbon is associated with this mix design, this batch from this plant right now. You want all of that information to actually be able to compare the materials that you're collecting. And then going on to LCI. LCI is we're really now starting to get into the weeds. That's the life cycle inventory. So that's all of the foreground data. That's the data that you're going to go out and collect from the plant, collect about the manufacturing process, collect about the materials, collect about the supply chain, and the background data. That's the databases you use to assign impacts from oftentimes prior LCAs about specific inputs to your manufacturing process. So in the case of something like concrete, that's going to be the information around the cement production, information around the aggregates production, that all come together to form the LCA for that mixture of cement and aggregate and admixtures and whatever else is going in there that you're going to use as your cement life cycle assessment. It's going to end up in the EPD document and be used in the procurement process when you're going to go and do your building level life cycle assessment. So hopefully that clarifies something.
Yes.
All the way down to the bottom and then back up to the top, and we can dig back into any of those topics as we go.
Yeah, that's fantastic. Thank you. EPD 101 in 5 minutes. I really appreciate that. Thank you. Hopefully, I don't know. I always find the level set to be a helpful thing, especially in this space. So next we'll go to Peter, and you use EPDs in your work, right? And you kind of work on the creation side and generation of EPDs. Peter, you use EPDs. And so when we're looking at procurement at agency scales or government scales, what do you look for in EPDs, considering standards and rules, both from a creation standpoint, but also from a compliance standpoint?
A lot. No, jokes aside, there's so much information that's listed within an EPD. Sometimes you can just look at it at face value and you're just like, what am I looking at? What do I need to look for? When we're talking about greenhouse gas emissions, there's a metric that's reported called global warming potential, or GWP. That's primarily reporting the greenhouse gas intensity of that material. Ben was giving a great example on everything that's going into a concrete mix. From the international standards, or ISO standard 21930, which governs the construction sector, there's 5 mandated environmental impact categories. GWP is one of them. There's also reporting related to acidification, depletion potential, eutrophication, depletion potential, photochemical smog, and there's a 5th one that I'm drawing a blank on. I need more coffee. But so there's 5 mandatory impact categories. And GWP is the one that's gained the most attention so far. But it's also GWP over what scale? What are we talking about? And in most of the EPDs that we're using, we're seeing today in the US, primarily over the information modules A1 to A3. A1 is reflective of the extraction of those raw materials, think cement, aggregates, et cetera, within a concrete mixture. A2 is the emissions associated with the transportation of those materials to the manufacturer. A3 is the impacts from the manufacturing activity itself. And having all that information outlined in that clear, transparent way really helps us be able to dig down into what is the intensity and where is that intensity coming from. In some of the older EPDs, they were grouping all the impacts from A1 to A3 together. I personally think they should be disaggregated, because when you're starting to go through in your procurement, well, you can look into where your source material is actually coming from. And even though A4, which is the transportation from the manufacturer to your project site, is not always reported, where you are sourcing your materials and what you then put into your material specifications influence where those upstream materials are coming from. So, for example, using the state of Florida, they, broadly speaking, do not have great aggregates. Oversimplification. You typically have to bring in aggregates sometimes as far away as Georgia or Canada for just the production of asphalt and concrete. It's atrocious from an emissions standpoint when you actually get into the A2 and you start seeing that EPDs in Florida for asphalt have an astronomically higher value than basically the rest of the country. And that comes down to those upstream materials and that A2 impact, which allows you in that procurement role, if you're already updating your specification to account for EPDs, you can then look into, can we use more locally produced, locally sourced materials, which influences that A2. So in addition to that, just some basic product information. What is the mixture? What is the product information? Can I align it with my submittals that are coming into the project site? Can I not align it? Things like that. When you're sitting on a project team, you do have the benefit of being in that AIANY organization where you know the functional use of the different product. So you're able to start making that apples to apples comparison, even though it's not covering the full life cycle of A1 to C4.
Awesome. Thank you so much. All right. And we'll now go to Jack with a similar question, same starting point, but different endpoint. You also use EPDs, right, in your work. That's a lot of what LCA software in general is based on, largely what LCA software is based on. And so to frame it maybe differently for you, what do you look for in EPDs, or maybe more broadly, like embodied carbon information in general, as like underlying C-scale, but also underlying kind of LCA tools broadly?
There's a few dimensions here. Ozone depletion potential.
Yes, that was
just check that last box. Love checking boxes. In the use of EPDs in project level LCA, I think I want to sort of like take a little bit of a step back there and just talk about what to me is the potential of architects and architecture and engineering as a discipline really doing LCA as part of the design process, is the ability to see all of this data in context. Often when you're comparing EPDs, you might be zoomed into a particular product category or choice. And is it this carpet tile or that carpet tile or this resilient floor? And you're really just looking at this like very small slice of the whole project. From our perspective, the thing you're able to do in project level LCA is figure out which of the hot spots matter most and focus limited attention and resources there. Like, it's no secret to anybody on this panel or in this room that the LCA space is extraordinarily complex. So we think of like project level LCA thinking as a way to bracket down complexity to focus on the decisions that really actually matter, and say like thanks but no thanks to the 100 other decisions you could focus on that might not actually move the needle so much. And I think that really to me is the power of thinking at the project level. Now, there's different data sources you're going to want to use for this. We'll say the places you look closely, hotspots you see, and places you don't. For instance, it might be acceptable to use something like an industry-wide EPD for something like your installation. If installation is a relatively small part of the project and you're not going to offer specific procurement guidance, specifications to the contractor in the selection of the installation. Hey, we're using this density of mineral wool, that's going to be okay. But maybe in your project LCA, you discover that in that same wall assembly, right, like there's a vapor barrier that has actually a pretty gnarly emissions profile. This is a reason that you're going to want to dig a step deeper, look at product-specific data, compare product-specific EPDs, and really make a selection based on that comparison within that product category. There's also, like crucially, so we're going through data types, industry-wide EPDs, product-specific EPDs. There's also parts of the building that are not covered by EPDs produced by industry. And I think this is something when you're looking at the project scale, you have to reckon with in a way that you don't necessarily, if you're just focused on, say, like a single EPD or a well-covered product category, things like fillers, different gasket materials, little plastics or metals that show up in a building. The fact of the matter is there's just not good EPD coverage of a lot of these, but we still need them involved or included in the description of the building so that we have a picture of all the environmental impacts. And that, I think, is like a reason to me why we need to think about building level LCA not just as a collection of EPDs multiplied by a coefficient of quantity, right? But really an attempt to describe all of this stuff going into a building, some parts of which we can really look very closely at with EPDs, some more generally, and some that EPDs don't cover. But I think, again, when we think about what this means in practice, there's all of this complexity means that really like we're trying to bracket out as much of that as possible at each phase to allow designers who are already balancing 20 other constraints on every decision, cost, schedule, aesthetics, performance, to like use EPDs. And that's why the digitalization work that's happening across the EPD ecosystem is really exciting to me, because it helps create mechanisms of comparability that help people focus on exactly the decision they need to make so that they can move on to the next thing that matters. Today, C-Scale has the whole EPD library deployed. You can get the PDF, you can look at the data. But then to really take those EPDs and use them in the project LCA, there's a lot of other stuff that needs to happen as well. Service life replacement, sometimes covered, sometimes not. What happens on the construction site with that material? Transportation scenarios for A4, similar to the ones that you mentioned for A2. end of life, right? End of life data remains a really big gap in the data ecosystem in North America. There's some data sources that exist, some that we expect to emerge in the next year and a half. And it really is, again, like the project level LCA has a whole different set of opportunities and pitfalls around, we'll say, the use of a particular EPD. I'll leave it there. Lots more to say, obviously.
No, thank you. So this is good because you're teeing up Ruchita perfectly, because you are in the practitioner space, right? You're almost like the end user in this scenario, right? And so my question to you is, you get to use and react to all of these technologies in your work, and can you share what you look for in LCA tools or tools in general, or maybe even kind of agency and regulatory standards and requirements and how they inform the design process?
Yeah, sure. So like Jack mentioned, we do focus on project level LCAs at AICOM a lot. We start from the concept and we try to see that project through into construction as well to see what that emission actually looks like for that building. Now, based on the design stage that we're addressing, we use different tools. We leverage the capabilities of different tools, what that tool can provide based on the intent of the analysis. So for example, in early stage, we tend to use an internal developed tool called AICOM 0. It's a great optioneering tool. What that tool helps us do is, from the get-go, understand what those hotspots are. That can help us with targeted decarbonization measures, helps us understand where we need to focus at optimization measures on, for example. So that's a great starting point where we compare different options, different alternatives to see how that moves the needle. As the design progresses, we have more detailed information on the design. We use tools like one-click LCA. So AICOM has an enterprise-wide license with one-click LCA, where we're able to use all their tools and their comprehensive database to refine our analysis. So we take that early stage assessment and we refine it using more details that are offered by tools like one-click, and further understand how to decarbonize the building or the asset that we're looking at. And at this stage, we're still looking at more generic information. We're using industry-wide EPDs to get an understanding of what those product selections need to look like to get to that decarbonization goal. Moving on, we also use tools like EC3 and Material Compass by one-click for a more targeted approach where we're selecting between two products to see which one works better. So there's two insulation options, for example, for us to understand what's regionally available, what's better for the project, and what helps with the decarbonization goals. We use more targeted tools like that. What I want to say is that I think it's important to get started in the concept level and use tools that help you kickstart that analysis, identify those hotspots, and then as you move into more detail, using different tools that help you develop more detailed analysis, using those and seeing that through in construction as well.
Amazing. Thank you all again. I keep saying that, but it's true. This is great. So I am going to jump a little bit because this is where we're going. And you've all talked a little bit in different ways about this idea of specificity and generality, whether it's kind of industry-wide versus product-specific EPDs, or like what scale of analysis you're doing, how granular your analysis can be. And inherent in all of this is an idea of uncertainty. There's a lot we don't know in this space. And so I'm curious to hear from all of you how you think about this uncertainty, how you interact with it on a daily basis. And like specifically, I think with respect to this kind of symposium topic, in the like digital technology space, what does that really like look like? And maybe we can kind of go in the same order. So Ben, Peter, to Ruchita.
Okay, really getting thrown into the deep end on this one. There's a few things in LCA conferences that are most likely to start fights. Allocation is one of them, and uncertainty is another. So how do we think about uncertainty? I like to think about uncertainty in the context of decision making. What are we actually trying to do here, and what decisions do we have in front of us that we need to make in the moment? overall, the goal that our entire industry has is decarbonization. So that's the number one thing that I would point you at if you're starting to think about what's the uncertainty profile I'm dealing with here. How do we make it not so that we're extremely confident that the absolute value of carbon that we are calculating is the right one, but how do we make it so that we are absolutely confident that we're moving in the right direction with the decisions that we're making? So I talked a lot about the EPD ecosystem and PCRs, and looking at some of the PCRs that have had a lot of laps on them, a lot of people going over them over and over and over again. So that's concrete, that's asphalt, that's steel, that's a lot of these really carbon intensive and high volume products. There's an implicit understanding of uncertainty in the way those documents were designed and those EPD ecosystems were designed, by just embracing the fact that some of our information is a little bit out of date in some of the databases. Some of our information is maybe not as specific about the supply chain as we would hope for. And so what can you do with that? If our goal is to decarbonize, we want everyone moving in the same direction. We want everyone calculating the same numbers in the same way. So we specify how to do the calculation. We specify the background data. So you shall use this electricity information. I think there's going to be some talk about that a little bit later. If you're in this location, you're going to use this number. If you're using this material, you're going to use this number, unless you have supply chain specific information. If you have more certainty than we have in our background data set, then you can increase your data quality, maybe reduce some of that uncertainty. But in general, you're not going to be making decisions that take your analysis and make it uncomparable to the others. So even if the absolute number is off from the actual amount of carbon that's going out there, if you're choosing between two materials that are analyzed under the same rules, using the same background data set, using sometimes the same software or software that's been compared, concrete industry, there was a lot of that work where this concept was proven out. There were multiple softwares developed according to the concrete PCR, and they wanted to make sure that this EPD ecosystem in concrete was good. So they cross-compared results. They did benchmarking of those softwares against each other with very, very small differences found. And those small differences that were found, they went back to the PCR, made some tweaks, and removed a bunch of that uncertainty from the process. So you're at least certain that your numbers are comparable to another set of numbers, and you can make a decision between two products that is directionally accurate. There's still going to be other uncertainty issues out there. There's things like qualitative matrices of data quality that you can go through, that sometimes people try to apply quantitative metrics to and get you to a number of your plus or minus this confidence interval. And that can be a useful tool. As engineers, we love to have that kind of information, but the actual decision-making context that we're in, being directionally accurate, I think is far more important for the actual problem we're trying to solve than having a real deep understanding of the joint distribution of the final, maybe it's this carbon number. Get it in the right direction first.
Yeah, so my hot take this morning is I really do not like the word uncertainty. Uncertainty, just as a word by itself, what does that mean? There are so many different ways you can take the word uncertainty. And I think in our day-to-day operations, it really comes down to what is the variability in the data that we're talking about? What is the granular of specificity as it relates to the EPD? Jack gave a great overview of industry average EPDs, product facility specific EPDs. Those are different specificity of how your data is going to be displayed. Whereas uncertainty it's a fairly abstract word, in my opinion. There is, an official LCA terminology, definition of it as it relates to uncertainty of the collected data that goes into a secondary LCI data point, then feeds into all of the work we talked about, all the different tools, all the different EPD generators, which is it's so far down in the weeds. We'll skip over it for the time being. But I think really what we're talking about is how specific the data is for us to make our decisions. I think getting the PCRs more specific, in certain regards even more prescriptive, to support those multiple tool generators, multiple EPD generators to be in existence so that we're getting more EPDs in a consistent fashion so we can do comparisons, are more important than outlining, well, what is my confidence interval? Or how confident I am that I'm using all of the upstream supply chain specific information. Because sometimes that may not be available. That's the reality of our projects. So sometimes we know a lot. Sometimes there are just gaps where we can spend $1 million, plug all the gaps. But then if we spend $1 million and we reduce the total greenhouse gas emissions of that project by a tiny fraction, where's the cost benefit analysis of spending $1 million on that to get really granular, really specific data versus saying, okay, or I could fix my system, fix my process, work on adding an additional line item to support further electrification of that asset. There's a trade-off there. And so in my perspective, really comes down to the specificity of data, product facility specific EPDs. I think that's where we've proven out in several different material categories. This is the right granularity. Efforts from the American Center for Lifecycle Assessment, as well as my former EPA program, really supported that as well through the different PCRs, which feeds into the work that Jack has done at C-Scale, the work that Rashida has done at AECOM to implement these at a systems level, and least but not least, all of Ben's work on actually producing the EPDs and taking the sometimes 90-page documents from the PCRs of just drilling into making sure we have specific rules for EPDs to support comparability and translating that into an EPD generator.
90 pages of decisions I don't get to make.
Yeah.
When we sort of zoom out to the project scale, there's two ways that uncertainty is described within the standards. And I think there's a third place to sort of, that sits like, we'll say adjacent to uncertainty, but actually is where I think a lot of the action happens. The first, obviously, is everything we've talked about, uncertainty in the background data. The EPDs, are they specific? Are they representative? Are they representative? This is a really important question to ask. When we look at the building scale, though, there's actually much more uncertainty about how much we know or think we know about what goes into the building. You are looking at a mass. How much concrete, right, is in that mass? If it's say in Rhino or something like Autodesk Forma. You are looking at an 8-inch generic wall in the Revit model, right? Like, what's in that 8-inch generic wall? And I think like this is often where the rubber meets the road in project LCA, is interpreting the partial data that we have about the way the building is put together and using it to infer everything else that happens. And I think this is really one of the major obstacles, especially in BIM LCA, because BIM looks like it's comprehensive and it has everything in there, but more often than not, there's major gaps, details aren't well put together. And this requires this complicated crosswalking of the specification documents with the BIM, with the LCA tool to really do that filling. And I think some tools, I looked at Tally as an example of a tool that's done this so well by embedding so much architectural expertise in the way that takeoffs happen within the tool. And other tools, one-click, it really relies on people who know how to interpret that data, and it's a process of filling all those gaps manually. And I think this gets to different ways that these things are embedded in workflows. From our perspective, it's really about making, we'll say, useful abstractions. And this gets to the kind of third thing that's not a formally kind of like, we'll say, accounted for uncertainty. But often when you talk about uncertainty, it's like you report the final number, and there's a plus or minus. But the uncertainty that everybody deals with day to day in this room is design uncertainty. There's an open space of decisions. This is not because there's uncertainty, it's because it's an open question, actually, whether that's metal cladding or whether it's EFIS, whether it's mineral wool, or whether it's sort of like a cellulose fiberboard, right? Like this, I think, is really the exciting space to me to play in and think in. And the question there is, how do we navigate that space of possibility, that design space during the design process to understand the difference between ambitious choices and business as usual choices? Understanding that gap, sort of like we'll say separate than our understanding of, well, what's the uncertainty in this particular number, is to me this sort of like the place we should be playing in, right? Is understanding the potential we have to do better in each of those decisions. I think to your point about, we'll say being directionally accurate.
Okay, I want to touch on two things here. So first, underscoring what Jack was saying about the uncertainty around how the inputs are developed. So for LCA, one of the main things that we need are a bill of quantities. We rely on, in the digital space, BIM models to get that information. So there's a lot of uncertainty around how these BIM models are made and how that information from those models gets read into all these tools that we use. So the first step to actually making the analysis more accurate is accurately developing these models, ensuring that all the components that are part of your scope of analysis are included in that model and also named accurately. They're assigned the correct materials, and you're not missing out on elements. Also around elements that are not models. So for example, rebar or steel studs, there needs to be some industry guidance on what an assumption could be to, for say, the foundation rebar. What is a reasonable assumption to take and estimate those quantities? So I think refining these inputs is one way to reduce that uncertainty into the model and refining it as the design develops, obviously. Adding more detail to your model and carrying those through into your LCA analysis helps build that model accurately. On the data side, we have two types of data that we're looking at. We're looking at specific data and generic data. I say we use both of these and need both of these. So when we look at a very specific or a product-specific carbon data, that's typically representing the carbon footprint of a specific product, a specific plant, a specific mix design, for example. And that information on an LCA, on a project level LCA, is not available to you as a user very late in the design, if not in construction. So while this high level of accuracy is important in actually calculating the carbon footprint, we use a lot of generic data to actually get to that stage where the early models are built using industry benchmarks or generic data to help identify where the carbon sits, and then using regional analysis or understanding what the market offers, developing these low carbon options to actually decarbonize the project. We then use this specific data in construction to actually track how the building performs and refine, if at all, if the carbon goals need to be refined or if better products need to be procured. All of that is also seen through in construction. So in terms of data, I feel like starting the analysis using generic data, but then also ensuring that you're tracking what actually happens in construction using as-built product-specific data. Make sure that you're actually reporting the actual footprint of the project or the building.
So I had like 18 more questions for all of you, but we're coming up on time, and I want to make sure that we have time for the other panels because I would love to hear you guys talk all morning long, but there are a lot of other amazing people that we also all want to hear from. So I will end maybe with one last question. I think, there's been a lot of high level, there's been a lot of like really, really deeply weedy, like our weeds have weeds level discussion. And it's like wonderful to hear each of your perspectives about like what the deeply technical kind of minutia is in this space and what kind of the broad scale issues are. And so I think there's like, that's something that I feel is a huge takeaway for anyone in this space, right? Like anyone in the LCA space or the EPD space knows about these weeds. Maybe you know some of the more weeds and the more weeds and the more weeds. And there is this bigger picture that we need to keep in mind. And so that for me is one of the biggest takeaways here. And I bet you're all thinking this is where I'm going to end, but it's not. So I actually don't want to end on that. I would like to kind of circle back to the topic of the symposium more broadly, which is the kind of digital technology space, and ask each of you, maybe now in reverse order, so starting with Rishita, like there's been so much evolution of technology in the EPD space and the LCA space over the last 10, 15 years. You're all dealing with it in different ways. You've all been dealing with it for a long time. What are you excited about next?
I would say better automation. So from a practitioner perspective, when I am conducting LCAs, I usually take a BIM model, take out quantities and transfer them to a LCA tool. An easy way to do it is to just automate it. And again, it goes back to how the BIM model is made and how you can accurately tie in those inputs into the model. But I think, more focus around streamlining, first of all, how BIM models can be made, and then automation of A, how those quantities are transferred onto the tool, and B, that they're mapped correctly to that data point that represents the material.
One thing that's really consistently exciting to me about the world of architecture is it's one of these sort of like now a mostly digital practice that has really real consequences in the way the world comes together. Every polyline that's drawn, every hatch that's made, like when this happens somewhere in the world, the supply chain tingles, you know, like somehow materials will be moved because of these decisions. And I think it's really like, how do we equip the people drawing those lines, printing those sets to help all of those small actions that they make as designers move global supply chains towards better outcomes. And I think this sort of connection between supply chain impacts and impacts at the building scale, this is the potential of LCA. And to make that potential real, we need LCA not just on a few headquarters projects every year, but on every building everywhere. So that really is, I think, like what I see is the potential here.
I'm going to give 2 rapid fire ones, if that's okay. So the first one is really pulling it all together and coming up with incentive and disincentive structures, connecting our whole project LCAs from final design to tracking on projects using A1 to A3 EPDs and quantifying A4 and A5 to reward general contractors who are then beating the carbon budgets that we're putting out from our whole project LCAs. They're still a little bit disconnected and there's some data gaps to work through, but with all the digitization work on just the sheer scale of EPDs that we now have there, the ability to transfer data digitally, there's no reason why this can't be the next step that we'll be crossing, not in 5 years, but in 2 or 3 years. And so that's really exciting for me. And then the second part, when you were talking about tingling supply chains, trade, it's a weird situation at the moment of we have really worked through all of the digital tools that we need to produce EPDs at scale, and not just industry average EPDs, but product and facility specific EPDs. So why there are carbon border adjustment mechanisms coming out from the European Union, United Kingdom, Australia, et cetera, that are taking a non-EPD centric approach and basically implementing a tariff before tariffs were cool without using EPDs is a bit of a weird disconnection at the moment. So I'm really excited to see how we could use EPDs to feed into those carbon border adjustment mechanisms. Because like Jack was saying, our products are going all across the world. We're exporting to Europe, we're exporting to Oceania, to Asia, to Africa, to South America, and we're also importing from all those regions too. And so in a scenario in which we do have a global supply chain and carbon border adjustment mechanisms are existing and all the digitization work we've done here in the building sector, there's no reason why we can't use EPDs beyond construction.
All right. Yeah, lots of exciting stuff happening. The international aspects, I think, are really important. The trade aspects are really important. Digital product passports are going to absolutely change the entire dynamic in the European Union, and that's going to affect all of our supply chains as well. I mean, if you're producing here and selling there, you're going to need to have this kind of information digitized and available. And that availability of digitized environmental information is going to really increase the ability to look at product-specific information and get past generic data, improve the generic data. And for me, I think the real cool part is the digitization getting end-to-end in this entire process and helping us scale the entire enterprise. So we've been really successful with basic construction materials, concrete, asphalt, steel, and that's really kind of a worldwide story. That's happening everywhere. And the next big step that we're really trying to take is how do we scale from these relatively commodified commodities into all the other products, into the MEP space, into these more complicated electrical and mechanical systems that are, I don't know if you've been paying attention to the world lately, getting purchased in an enormous number to fill data centers and to build buildings and all these other things where the complexity of the work, the complexity of the LCA is much higher. How do we take our automation systems and drive into that space? And that's something that we're working on really hard so that we can put, like in Open EPD database, we want to be able to put those kinds of materials and those kinds of products in there so that the people producing the goods that you're specifying, that you're buying, can give you the data that you need to make those high quality decisions. And once you've made all your design decisions, actually understand your final as-built carbon numbers so that you can do it even better the next time.
So on that note, Rushida, Jack, Ben, and Peter, thank you all again. That was wonderful. We have 5 minutes. So stand up, wiggle your legs, shake your arms, get some more coffee, whatever you need to do, and we will reconvene at 10:20.
Well, hi everybody. Oh, there you go. Perfect. All right. We have a very big teamwork in the back of the room. Nice. So hi everybody. I'm gonna introduce briefly our second panel of the day. So, and starting with myself, so I'm Carlos Cerezo. I'm Director of Sustainability at KPF Architects, and I, with Jeremy, co-chair the Decarbonization Subcommittee here at COTE in New York. And very, very excited to have this second discussion, jumping a little bit topics, and now speaking on a different aspect of decarbonization and buildings, right? And incredibly excited by the panel, which, as you can see, we lost one member in the way. The weather didn't help, so we're going to have our last panelist joining in Zoom, but I think it's going to be an amazing discussion. And I've just introduced them, starting here to my left with Shrek Napal, who is the CEO of Carbon Signal. Shresh is, for 25 years, has worked as a consultant in the built environment with a professional focus in understanding building performance, energy, and the interaction between the building envelope, the building form, and building energy use. But more recently, he jumped into the world of data analysis and kind of large-scale energy modeling and started Carbon Signal, which is a company that exists in the intersection between machine learning, environmental design, and building physics, right? So we're going to hear about him and what Carbon Signal does in a minute. Thank you for being here, Shresh. Next to Shresh, we have Michael Reed. Michael Reed is the Senior Director at Building Transformation at NYSERDA, where he leads the neighborhood scale transformation, multifamily buildings codes and standards, and program operations and partnership teams, which is a lot of things to lead. So thank you, Michael. Michael is here as representing, I think that everybody here has kind of a assigned role, if you will. Michael is representing not necessarily the grid, but the interest of somebody who's thinking about the grid and buildings as a whole, as opposed to individual interventions. Then we have Molly D. Ramasamy, who is a principal at the Deep Decarbonization Group at JBMB, a mechanical engineering firm here in New York. And Molly leads a team focused on decarbonization of the built environment, has successfully led decarbonization and electrification studies representing millions of square feet of real estate in New York and otherwise, including some of our projects. Many of the studies have led to public-private partnerships with state and city agencies, serving to demonstrate how decarbonization approaches are scalable, resource efficient, and promote grid flexibility, right? And Molly's here being the real-world person, if you will, so not only the engineer that has to deal with shenanigans from both the tech people and the architects, right? But also as the person that actually needs to deal with the concerns of an owner directly and face the consequences of how a building is actually run. And then last but not least, we have Timur Dogan, who is up here in the screen. Timur is an associate professor at Cornell, where he directs the MARC program and leads the cross-disciplinary environmental systems lab. His research focuses on the intersection between design, computation, building performance simulation, and geospatial analysis. But then out of his work, a number of modeling tools have been produced and spun out and turned into things that we actually, all of us in architecture, end up using in our day-to-day. Probably the most important one, and the one that he's representing here today, is Climate Studio. Climate Studio is an advanced daylight and energy modeling software developed by a company called Solema that if you work in an architecture office, probably you're familiar with, right? So a very, very exciting array of discussions. And like we did in the last panel, we're going to start with a very, very brief presentation by everybody to tell us about what they do. And then we'll go from there and we'll jump into questions. So if I can get the clicker, and if we can share the screen again. Thank you. All right. So the topic of our panel touches on this idea that when we think about decarbonizing the built environment from an operational perspective, we are not talking anymore only about how energy efficient a building is. We really need to think about how decisions that we made at the building scale support and enable decisions that we need to make at a grid scale, right? And it's not enough to really have the most efficient building. Suddenly you need to think about peak loads. You need to think about things that happen in the middle, right? Like thermal district, distributed generation, distributed storage, and try to enable those larger goals that we're setting at the grid, but at the building decision scale. So the question for our panelists is, what is the role of technology in all of this? And in particular, we're going to be talking a lot about energy modeling and data analysis. So with that, I'm going to pass it to Shresh.
All right. Hi, everyone. What I'm going to start with is how the existing building decarbonization market has matured over time, right? So the last decade or so has been about measurement and reporting. We understand our footprint. Then came investment and financial risk alignment, which said, even with the grid decarbonizing, we must cut our emissions buildings by at least half. Now, regulations are accelerating enforcement. That will need about 1 million buildings every year to go through retrofits. As a global industry, we're working on less than 10% of those buildings per year. Why? Because money. They say $2 trillion must be invested in retrofits every year for us to meet our climate goals. Less than 1% of that capital is allocated. Now, the skeptics in this room will say that there is very little capital, so the transition will stall. But the analytics in this room will see that each of these trends is exactly the same. It's just staggered in time. So capital will move. Capital can be deployed through sound investment decisions. What we need is the ability to make those decisions with confidence at scale. And that's the problem that we are solving for. With the data that organizations already have, however sparse or limited, this is going to get nerdy. We use physics-constrained probabilistic inference to develop building energy models that generate audit-grade, risk-calibrated retrofit roadmaps that inform decisions with confidence, building by building, but at building stock scale. And that is when the most transformative work happens. From some of our early work, this is in fact with Michael, planning for distributed energy resources for the Sunset Park neighborhood in Brooklyn, to one of the most ambitious electrification plans for Washington, D.C., to understanding grid readiness if the building stock was to electrify for New York City, to policy propensity models now for the entire Commonwealth of Massachusetts. From 25,000 buildings on this side to 2.5 million buildings for Massachusetts, the underlying models remain the same. Physics-informed, probabilistic inference for decision confidence. Because when confidence scales, this is an old slide, never mind. When confidence scales, that is when capital moves, that is when we all get hired to design and engineer. That is when implementation follows. And that's what we're all working for, right?
That was great. Can you just keep going? I'll cede my time.
Very, very TED Talky. I like it.
Yeah, it was very TED Talky, and you almost have like a turtleneck going on like Steve. So this is a slide that Carlos dropped in there. So just as a disclaimer, in case there's any technical details that aren't accurate, it didn't come from my sir.
My fault. I apologize.
We, for those of you who haven't worked with NYSERDA, we tend to have a lengthy approval process for anything that can see the public light of day. But basically, we have a set of very aggressive policy objectives vis-a-vis decarbonizing the grid, scaling up adoption of energy efficiency, and decarbonizing the other sectors of our economy, which the Climate Act, which was passed in 2019, really sets a series of ambitious targets that, over the intervening 6 years, we've learned a lot about kind of progress towards those goals and the importance of thinking about this transition as a generational or multi-generational journey that involves a very complex ecosystem. And so I think that, I really liked what Shresh had to say. And I think that what I want to show is this is a little outdated, but when we talk about building decarbonization, we are primarily talking about fuel switching of our space heating and domestic hot water from on-site fossil fuel combustion, for the most part, towards high efficiency heat pumps, as well as low carbon or no carbon thermal energy networks. And so what you see here is just a distribution of the existing heating systems as the data showed in New York City in the mid-2010s, more or less. And if you think about just how much has changed since 2012, right? Barack Obama was president. Everybody loved Uber. I could keep going, but I don't want to get into trouble. And now here we are in 2026 with software stocks in the tank because AI is going to apparently replace all of our jobs in the next 2 years. And yet, in that intervening time, the traditional multifamily buildings boiler keeps on ticking. Right? So the replacement cycle for heating systems is in the most optimistic timeline, 20 years. But a lot of these, old boilers are patched together and they keep on going, right? And for better or for worse. So I think that while this is where we are more or less still today, and Molly will talk about some of the really interesting progress we've made, the future is looking something like that. Now, this is 4 years outdated. There's not any window heat pumps in there, but basically, we are looking at a transition from fossil fuel dominated central systems to a much more diverse set of heating solutions that are kind of patched together through a variety of solutions, integrators, and companies to create an energy system that is less peaky, much, much, much lower carbon intensity, and I think it all hangs on what I'm about to say, and more affordable than energy is today.
Okay, great, thank you. Okay, so that was actually a really nice segue into some of the stuff that I'm going to talk about here, especially this idea of systems that now are more integrated, different players, different owners of data that's ultimately going into how these systems are operating. But just to give a little background before I kind of dive into that, Carlos already mentioned, but I'm with JB&B engineering firm with quite a bit of experience. We've been in business for over 110 years. And the reason that that's relevant is because we've seen all flavors of how systems on the HVAC side have been designed over the generations, and certainly how they're changing now. And so we've really leaned into this idea of decarbonization, which, as was alluded to here, we're talking about electrified buildings, right? We're talking about heat recovery, complex thermal layering, different strategies than have been used in the past. And the fact of the matter is that the next generation of low carbon buildings, and I have it written here and highlighted because I think it's really important, it's defined less by individual technologies that operate in a siloed manner, and it's more about integrated systems that interact over time. And that's relevant to this conversation because the data that comes out of those systems needs to talk to each other and eventually needs to talk to the grid to be able to reach this future that we're working towards, which is highly electrified, decarbonized, and grid flexible. So data and why it can be a great thing, I think we have some really good examples of where, when applied in the right way at the right scale, it can expedite things significantly. There are also ways in which data, specifically at the building level, can be a huge barrier, right? So what I'm showing here on the left is a real diagram of all of the people who own and operate data infrastructure in a real, fully electrified building. And just from the look of it, right, it's very complicated. There are a lot of people involved, and not all of them are necessarily working for the same people, reporting to the same entities. And so the data for those systems and how those systems need to work together becomes a real point of potential failure. So as we move into the future and we think about where data comes into play and what we need to correct for at the building scale, we're talking about things like fragmented system data, data quality issues, things that just simply aren't correct coming out of the meters, low interpretability, and I think, hopefully we'll get into this more later on, but data by itself is not necessarily useful. And so the point I want to take away sort of in this last couple minutes before we shift to the conversation is if we can't figure out how to appropriately get and use data at the building scale, it's going to be very hard to realize a future where we've scaled up to the city level or the state level or so on and so forth, right? And so thinking about how to use data at different scales, I think, is really kind of the conversation we're hoping to have here, and I look forward to doing that. And this is just sort of a reiteration of what I just said, what we want to solve for, right? And I think we'll get into that more. So I'll go ahead and just go ahead and pass it over to Timur.
Yeah. Are we switching to, there you go.
Okay, all right, I'll share my screen with the slides then. All right, thank you so much for the invitation and these wonderful kind of pitches that were made before here, I think, and thanks, Carlos, for the introduction. So I am coming kind of basically wearing two hats: the software developer hat from the Climate Studio Solema perspective, but also from the kind of professor, educator kind of round. And the third hat kind of embedded there is maybe the researcher. So maybe just to kind of maybe talk a little bit about picking up what Shrez said in the beginning. I think this is an amazing kind of, I really love the slides kind of talking about how the capital will follow. And so with Climate Studio, the main goal here, or motivation for us, was that we wanted to create software that empowers architects to kind of bring energy modeling, but also kind of modeling the human experience in a sense, like things like thermal comfort and daylighting, bring that as early on into the design process so that these topics can become talking points, data points in the decision-making process of architecture, but also help maybe convince a client of a design. And so I think we've kind of talked a lot about decarbonization, and I think the driver behind Climate Studio and the development is more the human experience, and decarbonization is kind of the great side effect of creating good architecture as a mission. So we've focused a lot on CAD to analytical model translation, making that process as smooth as possible. And there's still some work to do. And then making simulations fast, accessible, so that they can be integrated into the design process. And alongside that, there's of course numerous discussions around like, what do we simulate? How do we simulate it? At what resolution do we simulate it? What is the appropriate thing to do in the design process? And how do we visualize this then in a compelling way so that we can, influence some of the discussions in a positive way around design decision making and decarbonization. From the research perspective, I want to just share one project from our lab, which I think is really kind of connecting well with this panel. And this is kind of our work on creating these kind of digital reconstructions of cities that we then use for urban building energy modeling. And we have started working on this together with Ithaca when they announced that they wanted to be carbon neutral by 2030 a while back. And since then, we've kind of built a really large kind of pipeline that can model entire counties and larger metropolitan areas in great detail using kind of energy modeling technology, maybe kind of similar to what Shresh has shared. The idea here is working with the sustainability directors of these cities and the utilities together, kind of planning for the transition. So we spend a lot of time reconstructing a very accurate baseline model of the city, geometrically very accurate, as well as kind of from a building physics modeling perspective, very accurate. And we have shied away from using AI because we believe that physics-based modeling is still kind of the most reliable and trustworthy approach and the most flexible kind of moving forward as kind of questions may change. And this has been a really interesting kind of driver where we're learning about quite some interesting aspects. And so I think maybe the main conclusion for our modeling work in Ithaca is that this approach of simply switching fuels that was already mentioned is not helpful for the building owners in the sense. And it's maybe also not attractive. In many cases, this leads to higher energy costs. And so we are trying to leverage these tools now to help also to improve the building stock. By that, I want to kind of, again, reintroduce maybe the human experience into the discussion. When we talk about decarbonization, it's a massive driver for changing our building stock, and we need to do decarbonization. But it would be a shame if we also didn't improve the building stock for the human experience.
All right. Okay. Thank you very much. So of the 15 million questions that I have prepared, I'll try to compress those into something that we can manage here. But I want to start with, so the panel is set up a little bit so that we try to cover all scales of the problem, because this is truly a multi-scale problem, right? We are trying to marry this top-down decision-making of somebody who is planning for the future in terms of infrastructure, in the case of Michael, maybe trying to help decide where incentives go, which particular buildings, municipalities, programs are the most critical and when are they the most critical, right? And the decisions of somebody at the bottom that is driving a design or working with an owner. So, Shresh, you sit a little bit in the middle between those two worlds, and you're kind of on the data analysis, modeling side. So to set the table a little bit, and then I'll ask the other side of the coin to Michael about the same question, so can you paint a picture to the audience of, in your mind, to marry these two worlds, what data do we need? What granularity, is it just measured data? Do we need model data? As you know, like what ideally would we need in order to make that communication and that planning possible?
So the motive here is to be able to make decisions, right? So that we can implement action. It's not the lack of data that is a problem. It's I've said this earlier. It's our ability to extract actionable intelligence from whatever data we have that is the problem. Money will not move until investment is sound. Investment will not be sound until there is confidence. The thesis has been that we can only predict with confidence what the outcomes of an intervention will be if we have a lot of data. And our thesis is that to keep the cycle moving, to move on to the next step, start with whatever you have. Find out directionally accurate, uncertainty, confidence, all the things that were mentioned in the previous panel, all of them apply. From the million buildings that need to be retrofitted every year, find out what the high priorities are, find out where action should be taken, find out how capital can be allocated so that we can keep moving. So it's not the lack of data, it's the lack of decision making from the data that we have.
Okay. So to the decision maker. So Michael, would you say that's true? Like, do you have currently all the information that you would want to have in order to allocate programs, make decisions on the either policy making side or incentive side?
Yeah, so I think that I completely agree with what Shresh said in the sense of there's a tremendous amount of data out there. One of the big challenges is extracting that data, and then it is orchestration or kind of coordination challenge at the end of the day. So I think at a very kind of like targeted, answering this question in a targeted way, one way in which we are trying to evolve energy efficiency incentives is really to focus on low to moderate income households and how can ratepayer dollars, right, that come from everybody's payment of their electric Con Ed bill, for example, support reducing the energy burden on those households who are experiencing that most acutely. And it's not just energy efficiency incentives. We also have federal money for low-income heating or electricity assistance programs, right? So we have a lot of different funding sources, but it is very hard to coordinate those funding sources, and it's hard to align those funding sources with the data on where are the most energy impacted households. But the hardest thing to do is then to figure out how to effectively serve those households, right? The hardest thing about multifamily retrofits is coordinating, getting into the household, the apartment of the building, right? Like, so that's a coordination challenge. And sure, data is part of it, but like at the end of the day, it's a coordination challenge. Now, when we talk about energy systems planning, I think that, and I take the point from the previous panel that they really hate the term uncertainty, but we are in an incredible amount of uncertainty, right? It was not that long ago that everybody was really focused on how heating electrification was going to drive the grid. Well, that's not the primary concern right now. It's cooling and data centers, et cetera, right? So we are now in an environment in which electric consumption is projected to increase something like 3% year over year. We haven't been in that kind of environment in decades, and that has massive implications towards long-term energy system planning. And then I think the other kind of just thing to put on the table, because it's front and center in all of the political conversations, is this question of affordability. And so I think that so I think that there are really smart people, whether it's at the Public Service Commission, at the New York Independent System Operator, or at the different utilities or NYSERDA, who are working really hard on this problem. And we rely on a lot of partners to do this work. So we have like the Grid of the Future proceeding, which has been issued or kind of commissioned by the Public Service Commission, but we have Brattle Group figuring out what is the amount of demand flexibility that we could unlock through a series of actions between now and 2040 to significantly reduce the need for building out the grid to accommodate all the electrification and just for minimizing total system costs. So we have the analysis and the data. How precise is it? Reasonable people can disagree. The challenge is orchestrating the actors towards that sort of a goal.
All right. So then I'm going to do like the last round on this data question and then move to something else, and I'm going to move to Molly. Because you are having to design systems and figure out like what you are sending back up to the grid potentially, like you were talking about earlier, right? And this sort of interaction of systems that you were talking about is kind of the next generation of how we're thinking about decarbonization. So do you have what you need? Either from, I know that sometimes you don't have it from the building itself, but do you have what you need to know from what the grid needs from you when you're trying to contribute to the system?
I mean, generally across the board, the short answer is no. So at the building scale, and then I'll also talk about the grid scale. At the building scale, I really love this idea of like using data from a utility, for example, or what you have for moving in the right direction. I think that's absolutely correct. Once you get down the road, right, and you have people literally trying to allocate dollars for their capital plan in the upcoming year, you need a different kind of data. You need the granular data that's coming from your building systems. And specifically in this context, we're talking about loads, right? We're talking about load data to understand from a mechanical perspective, what kind of equipment do I need and what does that equipment need to be sized for to achieve the heating need or the cooling need of my building. And that data is very hard to come by, even in the most sophisticated of buildings. So I think that's sort of the first challenge. And as we start to get into, okay, well, you know, we have building management systems. In theory, this data does exist, right? We find that the answer in practice is no, it doesn't. Either the points weren't landed by the BMS vendor, the trends weren't set up to last for more than 6 months if they were. And then the combination of the data needed to actually give meaningful insight, I think that's such a good point, is not there, right? So maybe you get a trend for chill water temperature supply over a 12-day period. What does that necessarily tell you? You know what I mean? And you really have to be a data scientist, which is not something that's been needed in our industry, in our specific trade up until now. I would argue more and more it's relevant and necessary. And so, you know, as we start thinking about the grid, okay, my building needs to communicate with the grid, but if I don't trust the data, or I don't have the data, or my client doesn't trust the data, my operations team doesn't trust the data, then how can we send reliable signals to the grid and receive them in a way that enables grid flexibility to truly be realized? And so I think there's sort of this dichotomy between like big picture, how do we move in the right direction? How do we plan for the future? And I think we have a lot of really good stuff for that. I think it's when you actually get to the individual building. How big is the chiller? How big does the heat pump system need to be for heating? And how do you coordinate the different players to get that stuff sized, installed, and then managed in operations, that things tend to fall apart a little bit, but we know it's an issue and we're working on it. I don't want it all to be, you know, like doom and gloom. It's a problem that is solvable, right? It's just a matter of talking about it openly like we are today.
So you've mentioned a couple of things there that are interesting, right? Like load management and a couple of other things. Can you, for the audience, briefly give a description of what an ideal grid-enabled building looks like?
Yeah, an ideal grid-enabled building would be one that can modulate not just its overall consumption, but could shift its peak, right? Could shift how much it's using at any given point in time in response to what's happening on the grid. And so the specific technologies that we're talking about there, things like batteries, right, demand response from an operational standpoint. You do need to have a certain layer of intellect in the building systems to be able to actually understand, okay, what are the conditions for my occupants that need to be met and what's happening at the grid scale, and so how do I change things in a way to continue to satisfy both? But I think really the short answer is that it is a building that has the right things, the right people in place to be able to flatten peaks and shift peaks in response to what's actively happening in the grid at any given point in time.
And those are, some of those things are part of the plan, right? Meaning, if we think about what New York City says they want to do or what the state says they want to do, they're accounting on a certain degree of flexibility, storage, and capacity to shift things around in the grid so we can get to the amount of generation in terms of renewables that we need. So those are things that we need to happen at scale, right? They're not happening now, they're happening in very specific cases and individual instances. We need to happen at scale, and to your point, with some intelligence of how they're like orchestrated across the board, right? So this is a question maybe for you and for Michael as well. If data is part of the problem, but not the problem necessarily, what would you say are like the biggest issue? Is it that we don't have enough incentives, like financially speaking, for owners of buildings to spend the money to get the data, to test the systems, to whatever they need to do? Is it the distrust issue that has come up in both cases, right? Like both, it seems like both like the owner and the grid are like a little hesitant to buy into a system that maybe they don't know is going to respond to whatever they're doing and investing money on it. Like, is it a lack of like technical, expertise throughout in the built environment? Like, what are the real issues preventing this for like expanding and scaling up and moving forward?
Sure.
I think this is a little bit of an unsatisfying answer, but I think it's all of those things. But I'll kind of explain a little bit more. From a technical perspective, it's new stuff for all of us. Everybody is learning, right? And so as these systems are more complex, because they need to be for grid flexibility, for electrification, there's a learning curve for engineers, for operators, for building owners, for everybody. So that's part of it. I think there is also a lack of trust, and that's historical in terms of the data, right? Again, not an unsolvable problem, but it is a barrier psychologically for people to overcome. And then I think really what we're talking about here most fundamentally is a mindset shift, right? This idea of the importance of what I'll call operational technology, right? Which is the technology that's literally in the building, that's working with the operations and the brains. For a long time has had this sort of smart buildings tag associated with it, which feels like a nice to have, rather than something that's absolutely critical. And so I think as we move into the next generation of buildings and how buildings are designed, it's not just about the MEP systems, it's not just about the data that might be coming out of the master meters, it's about the operational technology infrastructure and how much time and effort people spend on getting it right in design, rather than trying to solve for it after the fact.
Yeah, I think it's like Lester Freeman from The Wire taught us, you gotta follow the money. And so I definitely think that right now, there is a fairly strong but blunt price signal to the larger commercial buildings around demand profile of the building. And what you see, at least with the kind of well-run buildings, is a lot has been done to reduce those demand charges or minimize those demand charges and work within the constraint that that price signal creates. That's point number one. And then point number two is, within the demand response paradigm, which is a whole nother topic, we have seen a lot of progress in recent years with aggregators who are now bundling, room ACs into a portfolio and providing services when the grid operator puts a call to that specific geography, and then compensating the households. And it's very interesting as a model. It has not scaled up at all. It has a long way to go. And then I think number three is like the past is not prologue. So I think that we are in a world right now that is changing really quickly on this specific topic. In December, the Public Service Commission ordered Con Edison to put together a reliability plan for all of Zone J, the entirety of Zone J. This has never happened before. So there's a RFI right now. If anybody wants to respond to it, they're due by March 6th. And then in June, Con Ed has to put forward a plan on how they're going to procure upwards of 125 megawatts of non-emitting demand flexibility resources by 2032, and up to 750 megawatts by 2036. That's 3/4 of a gigawatt. That's a lot. Now, we'll see how this all plays out. But just to say that, I think that things are shifting as we speak. And the final point I would make is on this mindset shift and on this data question, I do think that there are very legitimate questions from the system operator about how reliable buildings can be versus firm generation assets. And decarbonization, as much as that's a big motivator for me and many of us in the room, is not the fundamental motivator for the system operator. It's reliability and affordability.
I think that's a really good point, and it also ties a little bit to something that Timur said earlier, which is decarbonization and carbon in a way is that there is a goal, and it allows us to put things in a common metric. but often the decisions that end up happening in the built environment and in buildings are not necessarily driven by decarbonization reasons, unless those fall into either finance or policy requirements, right? Which Suresh mentioned at the beginning. So I'm going to shift for a minute to the technology side and the modeling tools, and ask a question or versions of a question to both Timur and Suresh, right? Because they're both presumably offering the solution to some of those gaps, right? Obviously not the trust and mindset gaps, but on theory, those could be helped by creating confidence in whoever is making the decisions at whatever scale, right? So, Timur, when you're thinking about building features and you're hearing from users that are caring about all of those other issues as well, occupant comfort, affordability, resilience of a building, and talking to architects, right? Because these discussions tend to veer far away from architecture, right? Which is an architect is kind of a strange feeling. We end up talking about systems and controls and things that maybe I don't spend most of my time designing necessarily. But the reality is that the building has a role on it, both from if you're talking about reducing loads, energy efficiency and design matter immensely, right? But also, we are usually the first person that is talking to every decision maker that is dealing with a specific building. So when you're developing Climate Studio, where you're developing these tools, how do you think about producing information that is useful to address these questions, right? How do you, what metrics are you thinking about? What do you think are the opportunities there to support this discussion and to make it easier to explain or to give confidence to a building owner, let's say?
Thank you for the question. Yeah, I mean, I think at Solemma, we believe that the architect's kind of most powerful lever is the shaping of the load through passive design, right? I think that has been true for a long time, and it's still true. Kind of how do we, when we design spaces and buildings, like what is in the architect's kind of core domain expertise, and how does that shape the loads, right? But we have more and more kind of technical solutions, and I think the architect's domain pushes into things like control strategies, and how does, for example, I'm hearing like demand response requires maybe a smart control strategy, but it also requires some way for the building to communicate that with the occupant, right? Like, your cooling will be shut off now, and you have to open windows or something like that, right? I think this is a completely new layer in design of spaces that I think would be quite thrilling to engage in as an architect and as a designer. But I think, in terms of the future of energy modeling tools, in a way, I feel like our tooling is pretty static, pretty focused on a single building, and a particular resolution, right? Like the analytical building energy models are very stuck in a particular resolution. And so what I'm seeing as a trend within Solemma is we're kind of going in two directions. Like we're going the larger scale direction, which you mentioned, right? Like interconnectedness with the neighboring building or the grid. And so we've implemented some very rudimentary things like dynamic pricing models into Climate Studio that help you kind of understand renewable energy, battery, storage value, and so forth. But also the load shaping might fall right into this, and like modeling this dynamic response. But I think there's a real question, like from a user interface development, like how do we make that easy, transparent, and intuitive? I think we're light years away from that still. And then the other direction is, I think, the more detailed human experience direction. More highly resolved thermal comfort metrics that we have built into the tool, which completely change the way you're interacting with a building energy model. You're uncovering things about the building that you haven't seen by just staring at the EUI graph, which is really interesting. It's very didactic in a way. I see this in the classroom that the students take completely different turns, and I think that's another really important component. Like how do we model a human experience? And we actually have very limited capabilities. We know we have thermal comfort models, but we do not have other well-being metrics that are really robust and grounded in science and lots of data. So I think that's a really interesting research direction to go to.
And I think when you talk about comfort, and Michael was talking about this question of reliability in the grid, right? I mean, I hope that those plans end up thinking about not only how do we guarantee reliability to a certain degree, but what happens when the reliability is not there, right? Like we have these snowstorms here. Last summer, the grid was relatively close to its capacity. I remember being in Massachusetts a few years ago with a big snowstorm and having a similar thing, right? Like we were like 2-3% to the limit of what the grid could provide at a particular time. So it seems that it's not only that maybe the tools need to start going beyond code compliance and maybe focusing more on loads, but also they might need to be focusing more on what happens when the power is not there and how that falls into how we design buildings. The other side of the tools, and going to Shresh, I think is that you've sort of painted at the beginning a picture that you kind of figured it out. Like we have the pieces together to like help make this decision. So I want to ask both, is that really true, right? And then, like that, you know, like based on what we've heard, it might seem that maybe that's not there yet. That's point one. And point two is, do we really need, how much technology do we really need to make these decisions, right?
All right, so first I'll answer the previous point that you raised. 100% of what we do is about trust building and mindset changing, right? How we do that is by using technology. We've only mentioned data science is coming in, right? So you have sparse data. Everybody believes that that is not enough to take a decision because you cannot be 100% confident in what the outcome will be if you were to implement an intervention. Fair enough. What if we ran every single possible scenario of entire uncertain design space? Jack mentioned that earlier. The previous panel said they don't like, Peter said, I don't think Peter is still in the room, uncertainty is a bad word. Uncertainty is my favorite word, right? So I believe that quantifying uncertainty and quantifying confidence is way more important than trying to get to a precise solution, which may have a lot of false precision embedded in it. So to the operator, to the decision maker, if I can give a full range of options, and I'll come back to Timur's point about how we convey this, worst case scenario, best case scenario. I don't know what's happening in your building, but this is the limit of what's plausible, this is the limit of what's possible, this is the limits of what's likely, and in that entire space, this is the best case scenario that can happen, this is the worst case scenario, and this is what is most likely to happen, right? That's probabilistic inference, that's physics-based models. And if I can then convey to my decision maker that this is how the entire universe works, right? All financial risk analysis, insurance, mortgage lending, large transactions, they're all based on risk analysis. Nobody has a lot of data. They create probabilistic models and they decide where they're investing billions of dollars. That's what we are trying to get to. Map the full scenario, build trust by saying worst case, best case, this is the confidence take decision. The important thing is, how do you then, this is our struggle right now, which is what Timur mentioned, because it's far away from that. How do we convey that confidence rather than, and I think Ben mentioned this, rather than showing from distribution bands or probability bands, which just seems like a lot of data on the screen, how do we just still tell somebody, I am telling you, go invest $75 million on this, just shut up and do it, because that is the return on investment, right? We are at that place. Our technology is at that place where it can do that. We just need to be able to start communicating that effectively.
So to that point, and this is the last question I'm going to ask on these, and then I'll have like a final question to try to wrap up this a little bit, but it seems like, and we've seen the same thing with LCA and EPDs, there has been this escalation, right, in how available all of these technologies, tools, modeling pieces are, right? I remember 10, 15 years ago where energy modeling was an obscure discipline that only those that were willing to write on an IDF enough and figure out how to put it together would be willing to deal with or build whatever, a DOE-R model or whatever it was. Now we're at a point that energy modeling in varieties and flavors is in so many places, to the point that New York is developing a performance-based code that is supposed to require all buildings, like the prescriptive path disappears, right? Everybody's supposed to some degree, make a calculation that suggests what a building might actually be using when in operation. And NYSERDA has energy modelers that are looking at particular things. CONED presumably has. Molly certainly uses energy modeling. So at all of these scales, there is some degree of these. Does that make sense, or should there be some shared infrastructure to all of these, right? Like, how are we going to deal with the fact that the person giving incentives to a building, the person checking code compliance, the person designing the building, are all going to have to depend on some sort of digital representation of the building, but they are not dependent on the same one. And this is kind of an intractable problem that is very old, right? But in a way, the more we get to all of these things converging, the more relevant it seems. So I don't know if you guys have any thoughts on all of these, right? Is there any value in the model that a designer built first and then Molly worked on, passing on, or being somehow a resource for somebody in NYSERDA that is looking at a whole district or a whole grid area, rather than just like measure data or something else?
I have some thoughts, yeah. I think it would be fantastic if we could share expertise and tools and perspectives more openly. Like, in general, I think our industry could benefit from more collaboration and less competition. That, unfortunately, is not how it is at the moment, but I would love to see a future where that actually is successful, where somebody like Suresh could come in and could give a huge number of people a certain level of confidence in moving forward, right? And then somebody else steps in, maybe it's Michael, and is trying to figure out, okay, well, how do we get them to the next layer of detail? And then it comes to our firm, where we're figuring out, okay, how do we really get into the weeds? If we could figure out that handoff, it would be transformational. I think two challenges to that. The first is that the technical tools themselves and the expertise in building them is still very siloed. Our energy models probably are so different than the energy models that are being built by the other folks on this call. The assumptions, the thinking that goes into it is all very different. And it's hard to share files. Literally, it's hard to share the files that have the data that are the energy models. But then again, I think this is another mind shift set where, you know, usually when people are sharing models, it's because somebody's trying to get you to somebody else, right? It's usually somebody is unhappy with something and they're trying to figure out who made an assumption that wasn't right. And I think, unfortunately, that mindset is what's preventing what we're talking about here, which is a brighter future where we could all benefit from better work, right? And so, again, a psychological issue that hopefully someday gets solved.
I always
I'll drop the mic
thought,
there.
So here you go. So what Molly said, right? Most of my career, we were very reluctant in sharing any energy models, and we always had a very long appendix at the end of an energy model report, which listed every single assumption because covered our backs. The reason why we're saying the energy results are these are because these are all of the assumptions. If you have a problem with the results, tell us you have a problem with the assumptions, and that's it, and I'm not sharing my IDF file ever because you will find mistakes. At least from our perspective right now, right? Physics does not change. The implications of decisions do not change. How building energy flows is very transparent because the process everybody understands. And part of that trust gets easier to digest when you're not trying to build precise models, right? Everything that we just spoke about was one model based on one set of assumptions that gives one set of results that you are required to act upon. And if that one set of results is misleading because an assumption goes wrong, everybody's scared that everything will fall apart. If this becomes a probabilistic model, a confidence quantified model, where it actually transparently tells you what the effect of each assumption is, the decision makers can very easily qualitatively and quantitatively analyze, this is my decision space. If the occupancy was to change in the future, or if the climate was to change in the future, or the operator was to operate the building differently in the future, this is the magnitude of impact that I will see in my results. Given that information, is it still worth investing in this technology or strategy or intervention or not? That's a decision for them to make. But it's completely transparent. It's Uncertainty, as we say in our work, is a first-class metric. It comes before the precise results of the energy model, and it helps take decisions that you can act on.
All right. Okay, so we'll have a last quick question, which is we've had a deep discussion about a very wide range of topics, right? And what is clear is, well, I think that there is a sort of a sense that the technology part of this discussion can actually help build that confidence, that there are a number of other reasons that are not technology and database that we have to overcome. Some of them in the decision-making process, and apparently some of them in how we treat each other, which is probably true. So the last question is a little bit open and like looking forward, but is if you had to identify one, rather than a loose, blurry thing, like one thing, can be very small, very specific to your work, but one thing, it could be a policy, it could be a way data is handled, it could be, you know, an attitude in a owner. If you could change one thing that you think moves this discussion forward, because it seems there's a lot to do, and that to Michael's point, they're in kind of a transformative point, what would it be?
I'll go first. I beat the peak. It is just, that is what drives so much of our cost and so much of our challenge vis-a-vis decarbonization, affordability, and reliability. So that isn't one specific solution, but I do think that that is the focus, is how do we address the top 100 hours or whatever of a given energy system's demand profile.
Kind of hijack that and say, would you say, I'm putting words in your mouth a little bit, would you say that it would be helpful if our energy codes force people into beating the peak?
Look, forcing people to do things isn't very popular right now.
Fair. Okay.
So I
encouraging people.
It's very helpful when our architect and engineering communities are aligned on a set of goals, and one of them being, how do we bring either new buildings or refurbish existing buildings in a manner that has a very smooth load profile.
Good, I'll take that. All right.
I'll just repeat what I earlier said. Just embrace uncertainty. Start taking decisions with confidence in mind, and don't jump to false precise model conclusions.
Mine's a little bit boring, but I think it would be really helpful if we had more emphasis on operational technology as a core discipline alongside mechanical, electrical, and plumbing. So I mean standards, I mean specs, I mean all the things that no one wants to read. If that could be part of the core design package, I think it would go a long way.
Awesome. Teamwork?
Oh boy, this is so hard. I have millions of things I would want to change, and I think we have to change all of them to make the biggest dent. But if I had to kind of choose, I think what we need to focus on is kind of cracking the incentive system around making the transformation happen. I think I want to tie this back to, I think, Shrest's first slide, which I think was brilliant in the sense, like, how do we make the capital move? How do we actually make things work? And I believe it's in uncovering the additional value that comes from decarbonization that we are not quantifying, that's not part of the financial model, and also the hidden cost of carbon emissions. I think those things, we have to bring them together. And like, if we are using a metric, and that be it dollars, that drives the decision making, we have to account for everything that, you know, is influenced by carbon emissions in buildings or energy in buildings. And so, yeah, I think it's a complicated thing to do, but I think it's a multi-objective, multi-dimensional challenge.
All right. Well, thank you so much, everybody, for that amazing discussion, for a great panel. And we'll have another mini break so you can stretch your legs, and then we'll be back in 5 minutes for our third and last panel. So thank you so much.
Okay, great. So this is the panel on construction decarbonization with digital technology. And I had the privilege of choosing this awesome panel, two of whom are remote today. So we do have them online, and we will be getting to them as well. So I'll just talk a little bit about the rationale for bringing these folks together. So we have, and I'm going to let them introduce themselves in more detail, but I'm just going to stay at sort of a high level. We have Rebecca Schmidt from Turner Construction. And I'm just going to skip you for 1 second. We have Angela Iraldi from Skanska. And so brought them here as users of technology from large construction management companies, that do other things as well. But, we have them here today for their work in the field, working with these technologies. And then we also have Bobby Johnston with us, sitting here in the middle. And Bobby's firm does construction as well. They also do design. They also do unbuilding, as they call it. And so they're a smaller firm working in maybe a bit of a more nimble space, maybe than it's easy for you guys to work in. And so there's sort of a complementary perspective from the user of some of these technologies. And then online with us today, unfortunately, Britton his flight got canceled yesterday, so he's with us virtually from Oklahoma, I think. And Britton, these are the last two are our technology folks. Britton works with Converge, which he'll talk more about, but is a concrete sensing technology. And then we also have Morgan Lewis, who is with Material Index, and Material Index is a vertically integrated company that does a lot of different things related to materials reuse, and so he's going to talk a lot about that. So this is what we're talking about: data-driven construction practices. And I just wanted to highlight, this is when I think about progress in the industry, it comes down to a lot about, random gray powders, I guess, and I guess you see a little bit of that too, but people, really. And so this is, when we were having some of these preparatory discussions about technology and data, multiple people brought up, is it okay to talk about, how important people are to making these changes? And absolutely, right? It's hypercritical to change, just the attitudes and the practices of the folks in the field, in the design phase of the work. But we also, if we're really going to be making change, I think about these two graphics a lot. And so I guess data is sort of the lurky purple dashed line here in my depiction. But if we want to really try to stay in these safe operating spaces, as on the donut economics graph on the left, I think the monitoring that data affords really helps us do that. And then also, if we're really trying to more rapidly advance some of the progress and the change that I think all of us here are, data and technology can really help us do that. It can help us scale those efforts. It can help us expedite those efforts and just be more organized in how we affect that change. And so, with that, I'm going to turn it over to Rebecca. Sure. Yep.
Thank you, Amanda. No, it's okay. Oh, okay. So I was going to go to the podium, but I think it makes sense just to say. So in construction, AI is actually starting to change how operational decisions get made, at least in large GCs. A few months ago, Turner became the first major construction management firm to fully deploy ChatGPT across our entire enterprise. That's over 15,000 people. So we're using it predominantly to accelerate knowledge transfer across our 1,500 plus active construction sites, along with our 50 offices. What we've seen so far to date, we are already experiencing save time, expanded capacities, and the ability to focus on higher value problem solving, which is really cool. Through ChatGPT, we also just recently developed and deployed a device called Safety Coach, which is available to anyone who wants to use it on a construction site. It's an AI-driven tool that uses video analytics to be able to identify at-risk behaviors on the job site. So the main intent with that is prevention and awareness, right? It's really cool. And I just want to say at Turner, we're also thinking about decarbonization in the same way. So in 2019, what you can see up here on the screen, Turner developed its own sustainability KPI tracker called Greenboard. We use it to measure and to manage our job site emissions from fuel use, from electricity use on our job sites. We also use it to manage our water use and waste and embodied carbon. So when we began tracking our emissions on our job sites, we weren't finding too many surprises, but I think what was really helpful with it was quantifying. Being able to show the superintendents on our job sites how the fuel intensity is driving performance on their job sites is really helpful. And so we've seen it more as a way of working sustainability and decarbonization into our operational process. In addition to tracking our job site emissions, we're also integrating embodied carbon analyses during the pre-construction phase of work. So during estimating, during procurement, we are looking at embodied carbon of concrete mixes, of steel, the big players, those are the two big ones. We're also looking at others as well, but we are able to really look at alternative structural systems along with embodied carbon from a constructability standpoint as well as a cost standpoint, and be able to provide that information to clients right away. And so embodied carbon is a factor now in the decision-making process of construction, which is really cool. And while I think that technology has been really helpful in collecting and processing and tracking and transmitting all of this information, I think what's been most impactful has been embedding what we're learning from these technologies into the standard processes that we already have to track cost, to track budget, and schedule, right? And the last piece that I want to mention is really crucial, and it comes down to leadership, right? When leadership values decarbonization, and that is shown throughout the company, that really drives project teams to be aware of it and to hold it as a priority. And so with that, the results follow. Thank you.
Thank you, Rebecca. Great to get that perspective. So next we're going to hear from Britton on Converge. Britton, are you there?
Yep, can you hear me? I think I was on mute.
We're not seeing your screen up here. Let's see. Here we go. Okay, now we're good.
All right, we good to go? All right, perfect. So good morning, everyone. Sorry I couldn't be there with you today. I was one of the many impacted by all the flight cancellations in LaGuardia over the last couple of days. So I'm coming to you from warm and sunny Oklahoma today. My name is Britton Morris. I'm a regional manager at Converge. And at Converge, we work primarily with contractors and engineers using embedded sensors to monitor concrete strength and temperature in real time. And on the surface, that sounds like a scheduling or a quality control, quality assurance tool. And historically, that's been how they've been used. Contractors want to know when they can safely strip the formwork or tension their cables. However, what we've seen over the last few years is that this real-time performance data is also a decarbonization tool, even if that's not what the original intent was. We all know concrete's responsible for more than 8% of global CO2 emissions. And on job sites, one of the biggest hidden carbon drivers isn't just the cement content it's risk and it's uncertainty. And so what do I mean by uncertainty in concrete? And what does that look like? So that looks like over-designing mixes. That looks like extending curing durations, running fossil fuel heaters longer than necessary, or hesitance to adopt lower carbon cement blends. What real-time sensing does is it reduces that uncertainty. And so when you can see actual strength gain, not just wait on 7-day cylinder breaks, you can do things like not only tension your PT cables at the optimal time, but you can also reduce temporary heating or optimize mixes as you move up throughout the building. In other words, this data allows our teams to shift from time-based assumptions to performance-based decisions. And I think that's really what this symposium is about. Decarbonization happens at scale. Decarbonization at scale happens when sustainable practices become operationally safer and easier than what they're used to doing. And so if we want lower carbon construction to become standard, we have to begin to embed these carbon conscious decision making directly into the workflows of those in the field. So our site supers, engineers, and the trades. Sensors aren't going to reduce carbon on their own, but reducing that uncertainty can actually change the behavior. And behavior change at scale is what we really need to do in the construction field. And I look forward to discussing more of this as we go throughout the panel.
Well said, Britton. All right. You want us, if you're able to stop sharing, oh, you did stop sharing your screen. Okay. Looking at the doorway. Oh, Philip, if you're able to switch us to back to our slides here, that would be great. Thanks. Later. Encore. Oh, no, it's not. Oh, yeah. Perfect. There you go. Thank you, Philip. Okay. And yeah, next we have Bobby.
All right. Thank you, Amanda, for the invitation, and to COTE. I'm going to give a very super brief overview of Co-Adaptive's decarbonization journey over the past decade as it relates to this. Starting with operational energy reduction in 2016, we began designing most of our projects to meet the Passive House standard. As the shift in the conversation went from operational energy to more about embodied energy, Co-Adaptive formed a construction arm in 2021 to be able to have a greater impact both on the healthier biogenic material procurement and material reuse, remanufacturing, and recycling in our projects. The ubiquitous smart plastic vapor control membrane, something that you see here on the left, is something that we've been trying to look for ways to design out of our projects. The reasons have been threefold. One, to reduce the intensive labor required to install them. Two, to make it less difficult to access and modify post-finishing. And three, to eliminate the inherent synthetic and adhesive intensive makeup. Looking at triple glaze passive house windows, pictured here on the right, with multiple gaskets, step profiling, which serves as both an air barrier and a vapor control assembly, has been an inspiration on what innovation could come next. Over the past 2 years, Co-Adaptive has been developing a non-structural wall furring panel that is, one, modular so that it can be prefabricated and quickly installed. Two, made from all reversible components with exposed fasteners so that it is designed for disassembly. Three, certified to meet Passive House standards. Four, not clad with monolithic drywall, but instead with express panelization. and 5 made from all biogenic materials. So this includes salvage timber, wood fiber insulation, cork, felt, and biorubbers. Over the next year, we will be testing various panels and connections on Governor's Island as part of their climating piloting program. And lastly, CodeAptive has been working with EDC on the deconstruction and salvage of several building materials at Hunter Bellevue School of Nursing, what will become Spark. As many of you know, this is a pilot program with EDC circular construction and design guidelines. Our team started in January of this year and has managed to salvage and rehome several materials already. I'll highlight one of these materials. It's a glazed ceramic block produced in the 1950s, where we are currently harvesting several thousands of blocks for the duration of this month. We're ending in a couple days. The innovation highlights of these blocks will include an NFC tag in every block that will contain a link to a material passport, a remanufactured process that will grade plus repair and embellish any small chips in the glazing to highlight the process and to reduce waste in the harvesting yield. And most importantly, production of an insert that will allow these blocks to be dry stacked so that they could be installed with unskilled labor, and that these can be designed for disassembly in their next use. I too look forward to the discussion, and thank you.
Thanks, Bobby. That's awesome. Angela.
Good morning, everyone. Angela Wiskanska. We are a global developer and construction management company. We also provide an array of other services, owners reps, sustainability consulting services, and other services as well across our markets. We really strive to be leaders, innovators, and advocates for sustainability and decarbonization in our built environment. And we do that in a lot of different ways. So we do that via our own internal commitments and take lessons learned from those efforts. Obviously, ongoing collaboration with our design partners, owners, and trade partners. Via our internal advanced technology group that's solely focused on data-driven technologies for the construction industry. And also ongoing research and development of different tools and resources that, again, focus on data gathering and transparency. So one of the images that you see on the screen here is a snapshot of our EC3 tool that was co-developed by Skanska, and it's kind of become the industry-recognized tool for reporting embodied carbon in building materials. So that's something that we focus on, as well as ongoing focus of development of tools for on-site emissions and other ways to decarb as well. So we have both local and national sustainability team member support and subject matter experts in mass timber, circularity, carbon, among others. We are continuing to work on some of the most sustainable projects in the country and really push the decarb envelope and innovation envelope. And I'll just also note the rendering that you see on the screen is a rendering of the New York Climate Exchange project that we are building on Governor's Island. It's going for Living Building Challenge. It is kind of the most rigorous green building rating system in the world. And we're hoping this project, one of its goals is obviously to be a sustainable project, but also really be a learning lab and incubator for sustainability innovation and to show what we can do in a dense urban environment, especially in the New York market. So thanks for having me.
Fantastic. Thanks, Angela. And last, Morgan, if you could share your screen. No.
Sure.
I don't think so. I think it's just transitioning.
Hopefully you can see that all okay.
it's almost.
How's that?
Yeah. No, I think it just transitions. It's okay.
Okay. Yeah. Okay, great. Hopefully you can all hear me okay. And nice to be with you today.
I can't quite see the screen just yet, almost, I think.
Okay.
Everyone just turn that way.
I don't think. Yeah, it's okay. I don't think you broke it. There we go. Okay, you're up.
Okay, great. Nice to be with you today. I'm actually an architect by background and studied a bit in New York, so nice to be with you virtually. I'm co-founder of Material Index. We provide circular economy services and technology, predominantly in the UK and Australia, and just doing our first working sustainability consultant on our first project in New York. I'll be kind of just talking a little bit about material reuse in construction. Why is that important? Because on average, it's about 60% of all waste in a developed economy comes from the strip out and demolition of buildings. There's a huge amount of carbon in those materials. Reusing those materials is a great way of saving on the production of new carbon-intensive materials. We find on the 200 projects we've been involved in, we have an average reuse rate of 19%. So there's a huge potential carbon saving from reuse. And we currently exist in a kind of world where it's actually quite easy to buy a refurbished laptop or car, but quite hard to specify a refurbished building product. The core of what we do as a business is enable very good pre-demolition audits to enable the salvage of materials. I won't go into kind of too much detail, but the kind of two core parts of that really are creating a great asset register of what's there. So you know what is salvageable and what you can do with that component. And then enabling collaboration. It's really, really important that sustainability consultants, architects, contractors, and clients understand what is in a building and how to get it out. And in the UK, we connect to our reclamation marketplace. Elsewhere, we provide internal marketplaces as well. It's all about reducing the risk associated with the reuse of materials. You need to show to everyone in the industry that it is viable to get materials out of buildings, and that means it's then viable to get them back in. And that's a great route to decarbonization. Thanks.
Thank you, Morgan. And I think, Philip, we're going to go back to the home screen here when you get a chance, but I can start the dialogue. And Britton and Morgan, we would like you guys to be up on the screen. So, Philip, if you can bring both of them up on the screen for the discussion, that would be great. And Morgan, you might need to, maybe you did stop sharing your screen, actually. Great. And then Britton, I don't know if you're hearing us, but if you can, okay, good, you're there. We just need to have Britton on the screen as well whenever you're able, Philip, alongside Morgan. Okay. I'm going to go ahead and get started with the first question for our discussion, though. Sometimes technology enables us to see things that we aren't able to see with our naked eyes. Sometimes it aids us in doing our work much more efficiently, and sometimes it helps us to apply data or algorithms that help us to achieve much greater scale than we might be able to otherwise, right? So what do you each see as technology's greatest opportunities or levers in the work that you guys are each doing? And I'll start with Rebecca.
Great. So in construction, we rely heavily on relationships and trust, right? We work with trade partners that we've had success with on past jobs. And so it makes sense that we would use technology in a similar function. So added clarity and confidence, right, in the data that we're getting. So any product that we would be using, we want to make sure that we're seeing either improved transparency, added certainty, which I know is a word that's been used a lot in the last couple of panels, or to support decision making. That is where I see the greatest value in construction.
Okay, fantastic. Bobby?
Yeah, I mean, I think, we use technology a lot in deconstruction in terms of non-destructive testing, looking for piping in walls before opening it up and putting saws through it. Same goes for looking for, metal fasteners and nails inside timber before cutting it. I think those are like really low-lying technologies. I can see, and I'm kind of curious with Morgan's technology, how we can improve circularity audits so that it de-risks some of the mobilization, constructability, deconstructability of these materials. Because I think what it really comes down to is making them financially viable, and that is kind of the hardest part of it right now. And I think that really unlocks that key of uncertainty. So I think that's where I see opportunities in just getting really good at it. And maybe it's totally manual, but I'm sure technology can play a good role in that.
Makes a lot of sense. You were also talking a little bit about some of the safety considerations, right? That where technology can aid in making people safer, right?
Yeah. Oh yeah, totally.
Okay, great. Angela?
Yeah, I mean, I think for me, it's time and leveling. I mean, we're always behind schedule, right? So I think technology has really helped us, again, in the resources that we've developed and continue to kind of see, being developed in the industry and giving that feedback to trade partners. But it's really about being able to kind of collate data and extract just the information that we need and make sure that they're comparable, right? It's like, again, using embodied carbon as an example, like before we had some of the tools that we have now, it's like we were looking at like hundreds of pages of EPDs trying to like decipher what the heck was going on. And I don't know if anyone's ever read an EPD, but they're like terrible. And you basically only need like one number on page like 37 of 56, so, and then sometimes they're not even, you can't even compare apples to apples. So we've come a long way in collating and kind of distilling down to just the information that we need. And I think if we can continue to do that, that's only going to make our work more efficient and have us focus on other priorities, but then also further other aspects of decarbonization.
Great, thanks, Angela. Britton.
Yeah, so I would say in my role, the biggest lever for tech is reducing that word uncertainty, reducing uncertainty at the moment that decisions are made on site. So we know our teams on site are constantly making high stakes calls, right? When to strip forms, when to tension, how to heat, how long to heat, whether to accept a new mix. And when there's uncertainty in this decision-making process, we generally see a default back to conservative options, right? Carbon-intensive choices. So what real-time sensing does is it, like I said in my intro, it shifts us from this time-based assumptions to performance-based decisions. So instead of it's been 7 days, we can tension, we can say the slab has actually reached its required strength, and we know that in real time. And the shift is small, but at scale, it enables and it unlocks a lot of these, lower carbon concrete mixes, reducing temporary heating, can shorten schedules, and it does all that without compromising safety. So for me, tech's greatest opportunity isn't just the automation piece, but it gives teams the confidence to make these lower carbon decisions in real time.
Great, thanks, Britton. Morgan, how about you?
Yeah, I guess from our perspective, a key thing is quite a sort of traditional attribute of tech is that it lowers operational complexity on site, lowers the price and the time spent doing labor-intensive activity of scheduling what's in the building. I think probably the most interesting thing it does is help shape workflows, though. And I think all tech kind of subtly alters the kind of workflow you go through. And, what one tries to do is to design it in a way that, makes collaboration easier and surfaces useful data at the point in the process that you need it. And I think everyone in construction knows that, there's always a complex web of stakeholders involved in every project, whether they're subcontractors or clients or consultants. And, good tech can basically simplify that.
Yep. I agree. Thanks. So, Angela, I'm wondering, especially thinking about projects like the climate exchange, how do you evolve, really progressive decarbonization practices on some of these maybe smaller, more niche or early stage projects in the use of a practice to application at broader scale across maybe most or all of your portfolio? And in doing so, do you find that there are certain technologies that are either quite useful in the pilot phase or when you go to scale? And can you give some examples?
Sure. When it comes to scaling decarbonization innovations in the built environment, we're almost always doing this balance of what I call the 3 C's, so cost, coordination, and carbon, right? And looking at all of those levers. And then obviously, scaling requires moving from proof of concept models to widespread adoption. And I think some of the issues that we see there in achieving scalability is lack of impact on a technology. Like, we developed this cool technology, but there's limited impact or undefined impact, and then also lack of education and or expertise at the trade level or the end user level. So I think data is incredibly important at the pilot level. I mean, it's important always, but it's incredibly important at the pilot level because that's when we can start to identify the impact of a technology and start to think about how that impact might extrapolate, right? And then it's also about de-risking a technology for owners and investors, right? And that needs to happen at the very beginning, before deployment. So, I can use an example working on the climate exchange project. So we are working with them. They launched a Sustainable Solutions Challenge this past year, where they did an open call for different startups, tech companies, sustainability enthusiasts from all over the world for different sustainability innovations. So it was materials, it was HVAC, it was carbon capture, it was a lot of different things. And they announced 2 cohorts of finalists at this past Climate Week. And we have been tasked with incorporating the finalists from cohort 1 into the new New York Climate Exchange project to really show the dedication and investment in these folks. So it's interesting because it's an exercise that we're working through right now to understand, okay, trying to outline, here's the impact of these things, here's the scalability of these things, and then also having all of these feedback loops between us, the manufacturers and the owners to kind of identify what are the opportunities, what are the barriers, right? And then given all of those things, how can we at least start to scale, maybe if not for this project, but look at other areas and opportunities where we can scale. And I think I just want to, make the point that I think it's really important, those feedback loops, right? So, I mean, I think that's such a large part of scaling, is to understand like what the barriers everyone's working against are, right? Because I feel like so often it's like, just do it. And it's like, no one, there's just not that feedback loop. So, like I said, quantifying impact is really important. That's something that we're working through now. I'll highlight just one pilot that we do have on the island right now that everyone can go see. One of the finalists. It is low carbon concrete, microalgae based cement replacement that dramatically reduces the carbon impact of the concrete, potential to make it carbon negative. Obviously, we know concrete is a huge contributor to global GHG emissions. So again, we're using this as a pilot to see how we can incorporate it into the project and at what scale.
Fantastic. Thanks, Angela. So the two of you, Bobby and Angela, and your companies, CoAdaptive and Skanska, are collaborating on material reuse on the Spark project. Can you talk a little bit more about, just how you are each tracking the data of that material reuse and how you're kind of coordinating on that so that you have the information that you need at the end of the project?
I was going to say, I can start and then give it to you, Bobby, because your input is more interesting than mine. So we are working on the Spark project in Kips Bay. I think we mentioned it earlier. It's the first project to follow EDC's circular design and construction guidelines. So focus, away from diversion landfill and really focus on reuse and deconstruction. And Bobby is one of our decon partners on that project. And Skanska's role really as the CM is to facilitate the outreach for partners, and then obviously facilitate the work that they are doing on site, and also making sure that we are quantifying all of the material and thus emissions avoided that we are reusing for the project. So.
Yeah. I think it's interesting when you look at how in construction, how you gather data versus maybe something like a BMS system where it's super automated. We do a lot of things through form-based information exchange, a lot of things in time cards and things like that. I think there's granularity between what we're tracking versus maybe what someone like the CM Skanska is tracking. I think the metrics that what we're sharing is the weight and quantity of the materials, the labor hours, and and where the materials are going in their next phase. Which we found several homes for two of the material streams. So on our end, we're tracking some maybe more granular metrics. We're looking at how long we're harvesting versus cleaning up the blocks on a first pass versus transporting them to say the loading dock, which is not an insignificant time. We timed just an empty pallet and that took 45 minutes. And I don't think we were anticipating that. And that makes a big impact when you're, transporting 100 pallets of material. So there's a lot of logistical challenges that we're trying to learn from in seeing, how many blocks we put on a pallet so that it's movable, and it then needs to get reprocessed to go into storage, and how do we, then somebody else has to move that material again. So I think it's all these different, keeping track of all these different things that we're looking at right now. And I think just as with Skanska, they built a lot of custom tools. I think maybe 2 years ago we started building our own software platforms through Airtable, but a pretty robust system where we can track different labor hours across projects and different subtasks, and just get really granular with what people are doing on site, because I think that does translate to being able to predict an outcome the more we do it. And with deconstruction, you know, it's a different building every time. It's a different team you know, the team itself, not the internal team. But it could also be a different internal team every time too, if you're doing workforce training and things like that. And that's one thing that we did do on this project is we brought in other like new team members just for this effort. We brought people across the country that were interested in deconstruction. So there's a lot of different variables, and I think they're all really important to track.
Super helpful to understand better. So I'm curious, Bobby, on projects. I don't know how many projects where you have the wonderful capability to design, unbuild, and build, do all three of those things, because I think that's probably a really wonderful advantage for you and the end product whenever that can happen. In those instances, are there certain technologies or tools that have, maybe it's what you just mentioned, maybe it's the kind of the Airtable, or, you know, are there like sort of linkages that help create a through line that enable you guys to be really successful in realizing the design inception at the end of construction?
Yeah, I would think that it would be something like Airtable or something like that too, but I feel like the more we have done this, things start for us in unbuilding. That's where our material streams come from. And then as architects and designers, we look at that and we're like, okay, what can we build with this material now? And then it's about how can we build with this so that we're not, you know, making, you know, mortaring more blocks together that is going to, you know, we're going to have to track the PPMs for someone cutting it and all the time intensity it takes and the silica dust and everything else. And so we look for ways to design for deconstruction. And I was thinking about it, and you know, I don't think design for deconstruction in itself is a technology. But I think all the particular instances of what you create out of that work plan is they are like little mini technologies. I think, you know, inventing an insert for these to make them more circular so that they can go into projects without this is something. Another example is technology that we're working with Cornell's Circular Construction Lab. And it's a NYSERDA grant that we won last month for...
Congratulations.
No, thanks. For a product called GrooveLam. And I have to give the CCL the credit for all the IP on it. But it's essentially looking at how we can make how to regrade existing timber and then make a structural beam out of it instead of a glue lam, something that doesn't use adhesives. It uses kind of scoring on the individual laminations of wood, and then binds them together mainly through kind of gravity connections and different dovetails. So they tested a bunch of different methods over the last couple of years. But I think, you know, that is a product that doesn't have adhesives. It can go back to the earth, or it can be, you know, downcycled afterwards. And I think it's just, you know, another example of how we can look at those types of technologies as something to strive for and to embed in our projects.
Fantastic. Okay. And just last, I'm wondering if you can talk a little bit about the technologies used for Passive House. I think you guys do a lot of work with Passive House, especially some of the adaptive reuse projects, kind of bringing these more historical buildings into the present day with very up-to-date technology, building envelope construction. And so I'm wondering, what you use in that process to make sure that you're meeting that standard.
Sure. Yeah, I mean, I think those technologies are pretty standard. I don't think we do anything super out of the ordinary. It's a lot of blower door testing. It's a lot of smoke tracking, old school smoke tracking to find leaks. We have dabbled in some of the the noise machine versions that you have a speaker somewhere and then it will ping the system if there's any leaks. And then infrared cameras. Those are kind of our go-to technologies in that. But with that, I think the main technology, going back to the slide I showed about this modular panel, is how we can design a system that is all about tapes and membranes right now and make it more like the windows, where it's something that could be gasketed, something that could be opened up easily. Because I don't know, if you open up a passive house, it could be a mess to track that down and to restitch those membranes together. And why can't we make it easier? So I feel like that is really the place to innovate right now.
Yeah, okay, thanks. So Rebecca, you're managing sustainability for Turner in seriously one of the most complex markets in the world. I'm wondering, as you introduce new tools and technologies into the field, what does training look like for superintendents, for the trades? I'm just wondering, making sure that that data leads to real improvements in the field and that the folks in the field feel empowered to be a part of that process as much in real time as possible. How do you make that happen?
I think I'll start by saying that decarbonization we see at Turner as sort of a broader push for adoption of all types of innovation. And in construction, there's two real non-negotiables. The first is safety and wellness. Second is operational excellence. And so any sensor, tracking device, platform, whatever, that we're trying to introduce into a project, at a very minimum, needs to respect those two priorities and ideally strengthen them. What we are seeing with data is that we are getting less variability, which superintendents appreciate because it protects the schedule, it protects the cost of projects. And so the training, it's not as much showing them a dashboard and being like, here's how you read the data. It's, here's the data, how do we operationalize it? And working together on that, right? So we need to figure out first, what decision are we trying to make and how does this data support that? And, a lot of the things that the project teams on the job sites already own, which are, schedule and risk mitigation and productivity, how can we improve those through this data? And the other piece that I think is really important is that we are able to incorporate these technologies into our existing workflows. So we have, regular OAC meetings, we have daily huddles, we have risk management meetings on a weekly basis. We need to be able to incorporate those easily, and we also need to have specific triggers so that if a specific number goes over a specific threshold, we need to act on it. And who's responsible? What are the next steps? Being able to operationalize it. Because without that, I think a lot of tools will fall flat. And so we really need to be sure that we can align them. And they also need to align with the specific risks that the project teams are trying to mitigate.
Yeah, thanks. Very helpful. So Rebecca and Morgan, I have a policy question for you guys. So Rebecca, having worked in the past for a city agency here, and Morgan living in a city with quite progressive environmental policy, what role do you each think that government could and should play in advancing some of this progress that we're talking about, whether it's about any aspect of decarbonization, how material efficiency nests under that topic? I'm just thinking that when you can achieve good policy, you really start to achieve scale, and that's sometimes what really makes some of these things work. So, any thoughts?
Do you want to start, Morgan?
Yeah, I can give you just a quick rundown of sort of what kind of happened in London over the last sort of 3 years, I guess. So it kind of rebranded the kind of waste part of the Greater London Authority, which was kind of the mayor's office, specifically focus on circular economy as well as waste. Rebranded it as Re-London. And then they introduced policies, particularly in the planning system. So less around building control, which is where a lot of decarb kind of activities take place, but actually in the planning system, and basically because that was the part of the kind of policy world they controlled. And what that means in practice is that large schemes which are referable to the mayor, and it's only very large schemes which are referable to the mayor, otherwise they're just decided at borough level, and our boroughs are much smaller than yours, basically have to submit a circular economy statement. And part of that is around tracking the carbon that's lost and doing a good audit. It had a good effect in that it made audits, which all kind of was always part of the process by damage contractors, basically improve and become like something that every project manager would get on every large project. And just introducing that into the process basically drove a participation, not just from us, but from contractors and sustainability consultants. So that's probably a bit of a recap. A lot of their activities have really been around collecting data more than instigating showpiece projects or kind of contracts for innovation, which tends to be how the national government works. So hopefully that was sort of useful.
Yeah, very helpful. Wish we had a circular economy statement that was required on all of our projects here, but one day we will soon, I think. Go ahead, Rebecca.
So as you just heard from Morgan, who's 5 hours and 2 decades ahead of us in terms of all of this, decarbonization is obviously very hugely driven by government. It's hard to talk about this in my current role, but I think part of why I was really interested in working for city government, and I really enjoyed that process, was because of the impact it has in decarbonizing our buildings. But what I learned firsthand is that policy does not automatically transfer mandate into action. And so I see government's role as more of a catalyst, and then there's a greater need. Both of you have mentioned de-risking, right? So to be able to move it from collective action to scale requires de-risking, and a lot of that happens through partners like NYSERDA, so thank you, Michael Reed, to be able to provide the technical support needed to transform the market into where it needs to be, along with the incentives, the funding. So looking back at when, the Bloomberg era local laws first came out on benchmarking, on energy audits and retro-commissioning, the first New York City Energy Code, all of that was really unfamiliar to the market at the time. So it needed to learn, right? And so the incentives, the technical support that NYSERDA provided through flex tech cost sharing, through incentivizing energy efficient equipment and products, which included fluorescent lighting, shows how far we've come. It was really helpful to be able to go from policy to compliance to where we are today, which is just our general standard, right? And so I see a lot of the same things happening today where we are able to decarbonize, but we do need those mechanisms in place to help transform the marketplace.
Makes a lot of sense. Thanks. So Britton and Morgan are two technology providers. We have so many different technologies that are available to us, right? And I'm just wondering if you believe that there are synergies in how we can better have them communicate with one another. For instance, I'm wondering if the data from a concrete sensor should eventually make its way into a material passport for that same material going forward, so that the owner of that building, which tends to change hands over time, understands exactly what went into that concrete and what might be able to be its destiny going forward in a major retrofit or deconstruction effort. And Britton,
yeah, I mean, I would say that I absolutely think that's where the industry needs to go. I mean, right now, at least in the data that we provide, that data dies at project turnover, or at least that's what we see. But we know and we believe that buildings are long-term material banks, and so the performance data should travel with that asset. So imagine a future owner not just knowing what mix was used, but also understanding how it performed, the curing conditions, street gains, cementitious material percentages. All those things can affect the durability modeling, retrofit planning, even reuse potential decades from now. The challenge isn't whether sensors can generate that data, because they already do. The challenge is more, the standardization piece of it. And if every tool we have, if it operates in a silo, we lose an enormous value. So we need shared data schemes and expectations that construction data is part of the building's long-term identity.
Well said. Morgan, anything to add?
Yeah, I think, it's not just around kind of material passports, but generally there's kind of a huge issue of construction information translating into like operation facilities for the life of the building. And I'm sure I'm not the first to say that. Even things like insurance, that's a big problem. I think to sort of echo Britton, actually, like standardization is a big part of that. Interoperability, obviously. What we often find as well is, you get to a certain scale and people want to build things in-house, which in some ways is really good, but that kind of can increase issues around interoperability. What we have found is that, the kind of biggest lever for getting construction information into the kind of like arms of the like long-term custodian of that building, and obviously there's often an ownership change. There's a developer and then an asset owner. It is really kind of like proving the return on investment on that, and often actually that often isn't really necessarily around decarbonization. It's often sort of saying like, actually this information is really, really going to make operating this building more efficient. Like we've got data which helps you with, the running cost of the building in X, Y, and Z. And that's what, we found. Just because, although the average lifespan of a London office, a central London office is about 6 years, central London retail unit is about 3. It's probably quite similar actually in New York. So a lot of these tenant level stuff is very short. So you'd think it really would make sense to keep hold of that data over that lifespan. You're not talking about 50 years. It's still far enough in advance that like the ROI over that period isn't the key thing that kind of sways their decision making around whether we should like pay extra to somehow make sure we collect that data properly and store it somewhere. Okay. Often the lead has to be somewhere else.
Mm-hmm. That's visibility and operability over time. That's the most compelling. Yeah, and that's what would enable us to maybe make these technologies a little bit more collaborative, huh? And Britton, just last, I think it would be helpful for people to understand a little bit better how, and your technology does a lot of different things. What I found most compelling from the perspective that I come from is the ability to reduce the massive amounts of fossil fuel heating that get thrown at concrete in the middle of winter when you're trying to come up to strength. I think it was Skanska in Scandinavia that I reached out to at one point a few years back to say, how do you guys do concrete in the middle of winter? Because I know that they were moving away from using fossil fuels. And I was like waiting for the email to come back, and I'm like, this is going to be the answer. And they're just like, we just stopped pouring. We just don't pour concrete in the middle of winter. And I'm like, well, that's not going to work in New York City. So then we met Britton, and he was helping us understand how your sensors can help with that, but also help us start to use some lower carbon concrete technologies and build the faith of the whole team in that technology, that concrete that's just this block of gray that we're like, I don't know what's happening in there, I don't know, I think it looks like it's doing what it's supposed to do. Can you tell us a little bit more about those two quickly?
Yeah, for sure. So I'll say the biggest barrier for both of those things in using in-place sensors for both of those use cases is fear, right? Because the superintendent never wants to be the person who let the concrete get too cold. They never want to be the person who accepted a mixed design that are going to have to go in and break out at a later date. And so going up to this, fueling in the winter, heating in the winter, what we generally see in the construction market is temperature starts approaching 40 degrees and they just put a tarp or a tent over their deck and you're just blasting heat on it for 7 days. Because you don't have any idea the actual temperature of your concrete.
Right? Not electric.
Correct. Not electric heat, fossil fuel heating. Because you don't know what your concrete's doing, right? And per the spec, you can't let it go below 40 degrees. And so in order to make sure that doesn't happen, you make sure it stays over 100 degrees. What we've learned in the past is you can just put sensors into the concrete to determine the real-time temperature of your concrete. And a lot of times the concrete doesn't get that cold. It's a chemical reaction that's happening within the concrete itself. And so a lot of times you can remove that heat either early. Sometimes you don't have to put heat on at all. You can put blankets on and that's sufficient. But the biggest barrier to that has always been, it's the fear factor, right? No one wants to be responsible for making that decision and letting their concrete get too cold. And that transitions over really well to enabling lower carbon mixes. Same kind of thing here. The biggest barrier is going to be fear, right? Most of the people we see on sites are not fans of low carbon mixes because of how unpredictable they're perceived to be and how much slower that they're getting their break data back. So with the use of real-time in-place temperature and strength monitoring, you'll be able to move as fast, if not faster than you were moving before with lower carbon mixes because you know exactly what your in-place concrete is doing.
Fantastic. Thank you, Britton. And I think we are going to need to leave it at that. And I just really appreciate all of the awesome insights. I know you guys aren't actually in that wall. I don't know where you're seeing us from, maybe right back there. But thank you guys for dialing in and making it work from the virtual perspective. And really appreciate all of your perspectives as well. Really appreciate Philip, I'm looking up into the door that I know you're sitting in. It's impressive how seamless the virtual aspect of this went. So just really, and Salmata as well. Really, really appreciate that. All of you folks organizing from AIA New York. And I learned a lot today. So thanks.
Thank you.
Thank you, everyone.
Thank you.